She's a little. Yeah, we're gonna tighten her up.
Get it.
How many do we remember? How many people went on live?
I think it max out as only 20.
Okay.
So,
Oh yeah.
all right, we're on live stream with one person, so don't say anything crazy.
Leave me alone.
Yes.
Maybe if this decided to break.
Women speakers this time around.
Yeah, they did. They got a good selection this year,
Yeah, seriously.
which is awesome.
I think all 4 speakers in the morning are women.
Love that.
Sweet.
What's that?
What's up?
It's just
You got the live stream working?
live stream. She's still a little crooked. I need to find something to like prop her up. Even I tightened it.
Just to overcompensate, so when it folds down a little bit, it's straight.
Just
Like the
Oh,
rotation.
yeah. I see what you're saying.
so wait.
He's like, bend it.
Can I?
Yeah, go for it. Yeah.
Is it falling?
What do you think? Is that still crooked?
We can't zoom in or anything.
I believe so.
Oh, there's like a. There we go. Is that better? No, probably worse. You can tell the truth. It's okay.
No, it's kind of hard to tell. It's easy to tell when you're.
It's not terrible. It's just hard to see. It's not. But
Yes.
Oh, it's still crooked.
Yeah.
That's annoying.
The only zoom in is getting closer.
just run in there.
Yeah.
Just run around the audio.
Oh yeah, can I flip this somehow? I think there's a way to flip it. Flip to like the video.
That's fine.
Yeah, it's more about like the audio.
Oh, I see what you're saying. Look at like.
Yeah.
Wow.
Let's just see. Flip YouTube.
Are these your both days?
No, just well, actually, I don't know. I might like get in here, but just like attend, but just like work, like in the side. I'm just like depending. I'm here. I don't know. So one day officially, because it's gonna be pretty low maintenance. I mean, there's so many more volunteers now that like I used to be doing 3 jobs at a time, like the earlier ones. Yeah, just like all right, I'm doing social media. Now I'm doing the live stream. All right, now I'm gonna go do this and do the music. I'm like, I was doing so much stuff like 2 years ago, 3 years ago.
Who's doing social?
Jeremy, he's doing a fantastic job.
What do we need to know, RJ? It looks like you got it rolling.
I think so. So it's really just monitoring. I'm going to get a link so we can start getting people in here via social media. Share. Copy.
So I'm assuming if for some reason the feed should go down, just refreshing.
Yeah, maybe this little guy right here, little reload the page if something goes off. If something goes off, then you can find me, and you have my number, so.
Double check.
Yeah.
Sure I do.
All right. So what craziness is going on back here?
Nothing. You're just
YouTube.
blocking the stream right now.
Yeah.
Nobody's watching.
Not yet, but hopefully soon.
Let's
go.
go.
So,
Yep, 733.
All right, so I think we're good. Monitor the chat. If anyone has any questions, we can try to find someone, but I think it'll be pretty
keynote
low
for sure.
Okay, thank you.
Yeah, for some reason, someone asked a question. So just say someone's got a question, and I'll find somebody.
Yeah,
I'll call her.
He's actually
Don't use my name. Don't use my name. I don't want you to worry me.
Bob, what do I do?
Okay, so make kind of my name over Robert.
Oh, there you go. I'm hungry.
All right, and then so the keynote though, we can definitely do that. Now, we're going to bring it up there now. And test it out. I'm gonna go find
Social media guy.
Okay, bye.
So you guys, so if folks know you're doing a live stream, will they not want to buy tickets? So like next year, or are they like, I'll just
I think
watch
it's the part of the benefit is being here too.
Yeah.
You know what I mean? Before we walk up there, all you
I
have
don't
to
know
do
if
is
we
see.
really advertise that we live stream it. It's more so we advertise
HTML.
in person and then live. It's also not, I think it's good to have like to share later on. Or I know we also have the video that yeah.
well, enough about work. Still doing jewelry? How's that going?
Not as much. I kind of took a break. I got burned out from it. So I've been painting a lot and house projects, and I started to learn how to sew. So I learned to use a sewing machine and.
She's a whiz at that, and I'm like, I don't.
Oh yeah.
Amanda's good at it, but I'm like, so I can't do models. I'm like, terrible at it.
It's tricky, I would say. So I made over breaks, like 2 jackets, and I was just like stressing out the first 2 days. But I had to get it up. I had to figure it out. So it was very stressful. You make clothes or something? You like what kind of stuff do you like? I mean, I try to make my own clothes. Yeah. That's awesome. Also, didn't I tell you that I live here?
Because you're in that new neighborhood that's kind of like right off.
How's it been going, man?
Yeah.
I just love when you take the
Yeah,
time
so
to
literally right there. It's awesome. I thought I was
Isn't that great? No, it is great. It never fails.
I texted her on the way out. And I was like, I'm not So, yeah, I haven't seen her since. But that's so funny.
That's awesome.
Yeah.
You like it?
I do. I really like it. It's been really relaxing. Neighborhood is just like sleepy time in that area. My ring alert is always like,
Yeah. There's always. I mean, it's so funny. There's like the whole B&B business going on right now.
oh yeah.
It never fails. There's like at 2 a.m. There's like double shots right now. And you're like, it's. I'm kind of like ever since we had kids, I've kind of been like sleep, but it's hard to like go into a deep sleep and she's all stuff. Like that's how she shuts her brain off before it. So I'm normally like so we just have sleep check in. I'm complaining about not having fresh broccoli. I'm like, your head, like really? But I told him I'm inspired right now because there was like a family like 2 weeks ago. It was like midnight. I don't think you were home until like. I just was like, So this is what. So there's like that church crossing, like you know that probably regret.
but I know you're around there.
Yeah, just in case you ever need. So like here's a social security office. Like here's your neighborhood. You come around the corner and there's like this little okay. Hey, you're going up Sunnybrook Road. There's like a little log cabin and like a 2-story White House shutters. Place your cars. We're like right up there. It's like up behind. It's hard to see cars. It's like a little. Like a 2-story White House with blue shutters and then there's a cabin to the left. But we went out. It's from home. Yeah, I'm telling you. This is hilarious. And we're like, look, it's good. Like you guys are fine. Doors, it's cool. So we made us this. We weren't in that much.
Oh, that's very slow.
Very slow burn. I wanted to like it those kind of shows. But anyway, we get this call. The call is from the we're scared. There's something weird going on. We hear all these weird noises. I'm like, where are you at? We're in the bathroom. Like we can hear like my brother. Like they're all freaking out. So all right, we go home. Get there. You don't hear it. Hear anything? And so I kind of like walk around the house and walk around the property, and then I hear like this growl. They're like, we hear screams and gunshots. So we're like, oh, shit, we gotta go. And then outside they're like, here, can you explain the sound? Like, not really, it's hard to explain. Basically, the church across the road is doing a parking lot business in Jurassic Park or Jurassic World.
Oh man.
It was like I walk in like, wait, I hear a T-Rex.
Like the dinosaurs.
No T-Rex back in the house.
Oh.
But it was so fun. But yeah, there's all sorts of different sounds out there. And I'm just waiting for something.
Well, there's a one time, I think I was some 2 months ago, there was an abandoned car literally for like 3 and then I was like,
Sorry about that.
oh yeah.
Damn, okay. Not again.
The only reason I found out was there was a hot light. The following like 30 minutes, I was upstairs. Going through the window trying to see what's going on.
The neighborhood always some dots section.
Yeah, you guys are really good at that. Mine is like one of the first ones.
That's how did I feel?
Really? We live on your side of like, you don't want to buy like a house like you, or like buy like,
This is one of the two it's like
A lot of these out
they
there.
are right around there.
yeah. That's mine.
It's a cool neighborhood. I mean, you could like Amanda takes baby on the same tracks, like all the time. Like it's like I think on that main strip of red, like all those houses down there. There's one house I'm doing like because there's like it's like if you leave, like if you go out your way, like you try to
Yeah, they're white. They're like when we went out of parts of there.
it's like a house on the right. Your leaves are up like waist.
Yeah. Almost like
I'm saying, yeah, like the cat. I'm usually walking our dog, like the other dog. It's dead, glass everywhere, trash.
I deal with like that's what like
That's true lie. I mean, yep. I'll show you. Yeah, they were from like 30 years ago. Yeah. New build. Burrito.
Yes.
Slow it out for you. Like, yeah, it's like I think you go out that door, the ones that they're on either side.
Okay.
What's up, You said yeah, obviously, yeah, I don't want that. Like that's a whole mind. But like it's in no, that's why it's just you're on the front line of the situation. Like my future fire, but like I basically all good. No panic, but Shane had a good idea. So Jeremy has the link. Oh. Well, I know the background. I wasn't able to get on that Wi-Fi. You have any trouble with it?
There we go.
Oh, nice. That's just be my phone. Normally when you do like a guest Wi-Fi, it like brings up the browser so you can like set terms.
Yeah, that's what it is.
Mine never did.
Try it again.
Mine's just my phone.
Oh, got to engage us next Thursday. Did you hear me? Have NJHS next Thursday.
What does that mean? What does that mean?
Like I have a meeting next week after school.
Oh, okay. So you just need picking up.
Right. I just wanted to let you know in case it interfered with their.
I can see the face as far as.
They were on the back, right next to like the back.
I think they actually have their. I think they have
I guess I gotta.
This thing kicks off at 9, right?
Yeah.
Or they gave them now. I think about it. Mother said she's being serious.
What do you mean?
She was like, "You're gonna be close to Daddy all day," and she's like, "How lovely."
Oh god. I said I want some alone time with you. If you think of anything you want to do together, please let me know.
Oh man. Sorry, love.
I don't know what to do. You're approaching. I don't know if it's just like he has three Yeah. I think I know. I was thinking about that. Yes. Yeah, this is Canada. You want to learn French? Not.
You haven't done this for 8 years, have you?
Like,
Or
here's some charges.
shit.
Were you gonna say?
No, nothing.
Oh crap! I forgot that I wasn't supposed to send a picture. I guess we're 1 for 1.
We're 1 for 1. Well, I didn't know I was supposed to not send a picture of you last night. It's all good. We saw a freak show last night in downtown Raleigh at the courthouse. It was awesome. I'm surprised I still have a voice. You like hooping and hollering?
This actually looks really good for you.
Some of my headphones, they're like just deciding to not work. It's irritating. No, you're fine, bro. I was just kidding about that.
That's a great fish.
Well, wait. You want them all?
Sure. I'll cherry pick some good ones.
Since you the iPhone.
Yeah, explain what that is.
How's everyone doing this morning? All right, on the count of 3, I want all of you to make as much noise so we can get more people to come into the room. Ready? 1, 2, 3. There we go. Let's see if that attracted 2 people. All right, we'll give it 1 more minute. Let's see if we can. Is Chris really chiming? I don't hear the chimes.
Chime!
As an Amazonian, that's a trigger word. All right, let's try it again. On 3. 1, 2, 3. That was good. Who was that over there? There we go. All right. Come on in, take a seat. Wherever you want to take it. Just return it at the end of the day tomorrow. All righty. Let's try. I still don't hear the chimes. Do you hear the chimes? There's not. We have a chime. We need a chime for Chris to chime. We go. I like it. I'm a big fan of puns. There it is. All right. Good morning, everybody. How are y'all doing this morning? Apparently, we didn't serve coffee this morning. How are we doing this morning? All right. I'm Nirmal Mehta. I'm the MC and your host for the next 2 days. Thank you for coming to DevOps Days, REU, or Raleigh, or Durham, or Triangle, or RTP, whatever you want to call this place. Who here is this the first time you've come to DevOps Days? Whoa. Welcome. I think that's like 90%. Well, welcome. So this is the 8th DevOps Days in Raleigh that we've done. It's a volunteer, so for most of you who are not familiar with DevOps Days, DevOps Days is an open source conference, meaning that it is all volunteer run. There are independent, roughly independent DevOps Days within lots of cities around the globe. This is ours. They have a local flavor, and it's all run by volunteers. So the folks that are in the salmon shirts or orange shirts or whatever color shirts they are, those are the volunteers that spend their spare time to organize this conference together for all of us in the Triangle area and for everyone who's watching online to foster a learning and education community around DevOps and technology within the Triangle. So before we get started, I'd like everyone here to do a big cheer for one of our organizers, Craig, who unfortunately couldn't make it to the event this year. And I want to just, we have a live stream going, so I want everyone to say hello to Craig on the count of 3, all right? Ready? 1, 2, 3. Hello, Craig! We miss you. Hope you can see this on the live stream. All right, let's get into it. Here we go. So before we start today, we have some housekeeping. Check your exits. They might be behind you. I think it's back there and to the left, the way you came, is the emergency exit. We have a code of conduct. It's on the website, so please follow the code of conduct while you're attending the conference. We want to make this a safe, fun experience for everyone. These are your friends, your neighbors, your colleagues that are here in this room today. So we'd like to keep a nice learning environment for all of us. So the next thing is food. That's the second most important thing after the emergency exits. Food is behind us for breakfast, and then there's a room for lunch. So when we do the lunch break, you can go to that lunch room. It's just behind, I guess, as you exit to the right is the lunchroom. And then the third thing is prizes. That's the third most important thing, and probably the reason you're all here, is for the raffle. So each one of you should have received a passport. You can go to each vendor booth and get your passport stamped, and then we have an awesome set of prizes to raffle away tomorrow. On top of that, Deutsche Bank is one of our sponsors this year. They have these posters that have QR codes. If you scan those QR codes, we will be raffling off Deutsche Bank prizes as well. So we've got a series of really awesome prizes. Get those passports stamped, go scan those QR codes, and stick around for the awesome talk by John Willis on burnout, and after that we'll do the raffle. The next thing is job board. So on the back of the room, there's a big whiteboard that says job board. If you are looking for a job or you have a open position or open positions or looking for candidates, this is a perfect environment to mingle, to connect, and put your information there. So if you're on both sides of that, go to the job board, put your info there, and we have this concept called open spaces in this conference, and I'll explain that in just a second. But we are also having open spaces for job kind of activities. So potentially we have recruiters here, we have other folks that are looking for candidates, we have folks that are looking for jobs. You can use those open spaces rooms to do interviews, to connect, etc. The next thing is the workshops. There are a few workshops today in the afternoon and tomorrow during the day. Those are in rooms 4 and 6. I believe they're over on this side. Yep, on your left. So if you are signed up or interested in the workshops during the afternoon sessions, I will make an announcement on when those start. You go to rooms 4 and 6. And then open spaces. Who here has participated in an open spaces before? All right, go find those people. All right, I'm gonna show you what open spaces is about. This concept is really neat. It's a unique part of the DevOps Days conferences around the world. The concept is that this is your conference as well. It's not just the presenters and the keynotes and the Ignite talks, but this is your space to dig into topics that you're interested in. So we have a bunch of rooms dedicated for open spaces listed on this board right here. And there's 4 principles to open spaces. The first is whoever comes are the right people to that open space. Whenever it starts is the right time. Whatever happens is the only thing that can happen. And whenever it's over, it's over. It's super zen. I just realized, like super zen. And there's one law. If you find yourself in a situation where you're not learning or contributing, just move somewhere else where you can. And the idea here is that if you're interested in a specific topic or hosting an open space, you can come here, write your topic on these cards, on these sticky notes. We have pens and sticky notes. Find an open space block on this whiteboard and just put it up there. During the break, folks will come up here to take a look at what topics are available. And during the open spaces session in the afternoon, they'll go to your room and you can talk about that topic. Follow those 4 principles. Make sense? So during the lunch break or during the morning, please come over here as much as you want to and put topics here. We have a few right now. There's one app infrastructure metrics on the hybrid cloud, super interesting. And another one, intern GPT. Share the who, why you are using AI at your day job. Also very super interesting. And I wish I could attend an open space, but I do these up here. So please check out the open spaces board. All right. The last thing is we have a quiet room. We have quiet rooms in 3 and 5. If today gets a little bit overwhelming for you and you need a quiet spot to reflect on how ChatGPT is going to take over our lives, you can check out rooms 3 and 5. You can also do other things in that room. Just stay quiet. And then the last thing, the most important thing, is to enjoy, learn, connect, and just have a good time. We're all about having fun. So one last time, let's do a big yell and a big energy release on 3. Ready? 1, 2, 3. Welcome to DevOps Days Raleigh, and without further ado, I'd like to introduce a friend, a colleague, the awesome Julie Jones. Please give a warm welcome.
All right, can you all hear me? All right. Cross your fingers. We're gonna hope this works. Yes. Such quiet anticipation. So I'll just let you all know while we're trying to get set up. I'm from Boise, Idaho, and we're called the City of Trees. And then I came to Raleigh. And I thought I knew, and this is my second time here, but y'all are so lucky. Your trees are so tall, and where I'm staying, which is by campus, it's like I'm in the middle of a forest. Like I walked out today and I'm taking pictures of the trees. So I hope you really appreciate how amazing it is here and how beautiful it is. It snowed in Boise last week. and then hit 85 yesterday. So we're all over the place, but it's absolutely amazing here. So it looks like we're starting to work. Just a second. There we go. Magic has happened. So, hi, I am so excited to be here. I saw all those hands for people who have been, this is their first DevOps days, and it's really exciting to see all the new faces in the crowd. I'm here to talk to you today about how we can apply our systems thinking to our humans. So really quickly, first of all, can everybody raise one hand? All right, great, you can lower them. I'm going to ask you to do some hand raising, so I just want to make sure that there were no technical difficulties there either. So, who has seen this image? All right, just a couple of hands. So these are the famous death balls, the service dependency diagrams from Amazon, Twitter, and Netflix, and these are old. I think these are circa 2015. And when we look at these, what you can see is complex systems, interconnected systems, systems with a lot of dependencies. And when we have complex systems, we know that our systems can fail. It's not an if they're going to fail, it's a when our systems are going to fail. And so these are things that we're always thinking about with our technical systems is how can we make them more reliable? How can we be resilient to failure, or how can we recover from failure quickly, and how can we learn from that? So that's what I'm going to talk a little bit about. Because while those systems are complex, when we look at the human system and all the systems within, whether or not it's the circulatory system or respiratory system, nervous system, we are also very complex. And our systems are dependent on one another. So oftentimes something that affects one area will affect another system. And so how can we make our humans who work on our technical systems more resilient to failure? Now, Nirmal, thank you for introducing me. So I am Julie Gunderson. I'm a senior developer advocate with AWS. Prior to AWS, I was at Gremlin, where I talked a lot about chaos engineering. And before that, I was at PagerDuty, where I talked a lot about incident response, which really ties up under the umbrella of reliability. Now, for my shameless plug, one of the things that I did in my first 10 months at AWS is I launched a collective on Stack Overflow. So if you're a Stack Overflow user and want to find questions and answers related to AWS, join us here. But I'm talking today about applying systems thinking to our humans, right? Well, one of the things that we think about in our systems that I'm going to talk a little bit more about is redundancy. And I was actually supposed to be joined by Anna Margarita Medina today. But last week I got a ping on Slack. Anna asked me if we could talk. We did a quick huddle, which was such a great feature just to be able to huddle everybody and chat with them. And Anna is unfortunately now recovering from COVID. So she couldn't be here today. That was okay, because we had redundancy built in. There were two of us. If one of us couldn't make it, the other one could be here to give the talk. So these are some of the things that we're going to be talking about. Now, I'm going to be talking a bit about reliability. And according to the well-architected framework from AWS, reliability is the ability of a workflow to perform its intended function correctly and consistently when it's expected to. Now, I think one of the things that we've all seen, especially over the last 3 years, is there's an absolute global increase in the push for reliability. Because our systems, everything now is so dependent on our technical systems. We can talk about safety, your airline systems, your transportation systems, medical equipment in hospitals. The economic impact of some of our systems go down. If our systems suffer a major outage, we don't just hear about it at conferences anymore. We hear about it on headline news. That can also affect the reputation of a company. And then quality of life. So by a show of hands, well, it should be all of us, but we spent the last 3 years at home binge watching Netflix. Okay, apparently not all of us. But with that, our quality of life was greatly impacted by technology. Folks were able to order groceries and food and have it delivered to their house, binge watch Netflix or Hulu or whatever it is that you're watching. But technology impacts all areas of our life, impacts the environment, with wastewater treatment, and companies' reputation. So that increase in the push for reliability, that can lead to a lot of stress on our humans. Now we have the burden of the world on our shoulders to make sure that our systems are working. So I want to talk a little bit about the principles of reliability. And here are just a few of them. But one of the principles is to automatically recover from failure. So what automation do we have built into our systems that can alert us on things like KPIs that directly relate to business values? What do we have built into our systems where they can automatically recover from failure on their own? We also want to make sure that we're testing our recovery procedures. So we don't just want to assume that everything works. That's not how we roll. We test our procedures to make sure that our systems can withstand failure and that they can recover in a way that we expect. And we also scale horizontally. So we take that one huge, large workload, and we want to break these up into smaller workloads so that there's not a single point of failure. Because we want to make sure that if somebody else's system goes down, the rest can keep working. One of the common points of failure is resources. So stop guessing at capacity. And we'll talk about that as well with our humans. And then we want to manage change through automation. So any changes into your infrastructure should be done with automation that can be tracked and reviewed. So these are just some of the principles of reliability. But there's a lot of parallels between system reliability and human reliability. So dependability, what you see here is that technical and human systems should be dependable. They should be able to perform their intended functions correctly and consistently. Sounds a lot like the definition of reliability. And when we look at that in our technical systems, we measure this with metrics. Oftentimes, failure rate or mean time between failure rates. And with our humans, we look at, are they able to perform tasks or follow processes or procedures, and are they able to do this regularly and consistently? And then redundancy, you already heard me talk about that, because Anna, which we should all wave at her, because I believe she's watching. So hi, Anna. I'll say hi to her. We want to have redundancy built into our human systems as well. Because with our technical systems, we build in backup components or parallel systems. But with our human systems, we can build in redundancy through cross-training, through having other members of the team that can perform tasks. Through in our own personal lives, not being a single point of failure, if possible. Because we want to make sure that you can recover easily when something happens. Adaptability. Again, we've all been through this. So adaptability is being able to cope with change and changing conditions and new challenges. And with our systems, we do that through software updates or hardware updates or flexible system design. With our humans, we can cross-train, we can learn more, we can build relationships, and we can work to make sure, again, that we don't have a single point of failure and that we are in a culture that embraces both failure and change so that we can learn. And then finally, resilience, and this is not an all-encompassing list, but they did only give me a half hour to talk to you today. Resilience refers to the ability of a system to recover from failure, disruption, and adverse effects or events. So we do this through fault-tolerant design. We do this through testing or chaos engineering to make sure that we understand our systems and that they can recover. So we can also do this to our humans. We can do it for our humans in our teams or in our personal lives. by exhibiting emotional intelligence, by using stress management techniques, or building relationships within our teams or in our personal lives. And the reason that I'm talking about all of this is really so that we can understand some of the signs of burnout, how we can avoid it, handle it, and recover from it. And John Willis is actually going to talk about burnout as well, and the conference in Leave on the last day. So, a German-born American psychologist, Herbert Freudenberger, in 1980, was one of the first people to really start talking about burnout. And he wrote a book, and this was his definition of burnout: so the state of mental and physical exhaustion caused by one's professional life. Now, I am going to preface with, I am not a psychologist, but I think that this definition is missing something. It says in the professional life, but our personal lives can also contribute to burnouts. Family, financial issues, stress, all of the things that our personal life has, can contribute and will contribute to workplace burnout or just straight up personal burnout. Who here that's willing to share has experienced some form of burnout? Okay, that is a lot of hands. Now, by another show of hands, when you were experiencing it, did you know what was happening leading up to it? Did you know that you were experiencing burnout? All right, one nod and then a verbal nod. So we're going to talk a little bit about that, because if we understand what's happening, then we know how to tackle it. I'm just going to keep track of time here, make sure I don't go over. Again, I'm not a psychologist, but burnout is not depression. It absolutely can lead you there, though, if you don't take the right steps to work through it. So just some of the signs, and again, this is not an exhaustive list, of burnout are listed here, but are you experiencing exhaustion? Are you tired? Do you have a lack of focus at work? Are you starting to get irritated with coworkers, maybe angry, and you don't really know why? For me, my side, it's a great one. I cry over everything. The first time that happened to me, I didn't know how to handle it because it would happen on meetings. And it was a very embarrassing situation. I didn't know what to do. So then I got so afraid of this happening that I'd have anxiety attacks about whether or not I was pregnant, because then we could cry. Once I started understanding what I was experiencing, it helped me find ways to work through this so that I didn't get into what I like to call the depths. And so again, not all of the symptoms, but some of the symptoms of burnout, or some of the signs of burnout. And when we talk about burnout, let's talk about it in our technical terms. This can be seen as maybe a sub-1 incident in humans. So an incident is any unplanned degradation or outage of our services. So what do we do when we have an incident? We have incident response. And we have processes that we follow. An incident response is an organized approach to addressing and managing an incident. So by another show of hands, who has all either been on the call with all the little windows or in a war room during an incident and people are talking over each other, there's a lot of yelling, maybe a sea level coming in saying, what's it going to be fixed? All right, too many hands for my liking, but I think we've all been there. Conversely, who has been on a call or in a war room during an incident where it's calm, there's generally a leader, people know what their roles and responsibilities are, and the sea levels are kept at bay by somebody else. All right, so we've got some hands there. So that's that organized approach. And when you have that organized and calm approach, you can really work to resolve the incident a lot faster and with a lot less stress. Because when we look at the goal of incident response in our technical system, it's to handle a situation that limits damage and reduces recovery time and costs. Which when we apply that thinking to our humans and a human incident, how can we handle that in the most calm way that we can in a stressful situation? So incident response in our technical systems, we have these steps that we go through. So preparation. That's the first thing. We've got processes, we've got roles, we've got guidelines. People know what to expect on an incident call. Hopefully they've practiced so that at 2 o'clock in the morning, you're running off of muscle memory versus a cup of really stale coffee. So we prepared. Now we have an incident, fires off, PagerDuty alerts us, we've detected it. We go in and assess that incident. What's the severity here? Is this a sub one? Do I need to drop everything and fix it right now, or can this wait maybe till business hours? We then respond by mobilizing the right people, and we work towards resolution of that incident and recovery, sending our systems back into a steady state. And then ideally, we are conducting postmortems so that we can learn from that incident and identify those contributing factors that led us there. Some people could say that life is just one ongoing suffering. We have incidents in our life, right? So how can we apply our incident response practices to our life? Well, we can prepare just like we would with incident response. Now this one, you can create your own personal incident response plan. And one of the things that you can do here is just make a list of who to contact if certain things happen. It's actually a great idea. You should have it on, you should have it in your phone, because you might not be able to call somebody, other people might need to make a call for you. And this can be people from your financial institution to therapists or doctors, family members, and friends. Have that list handy for different scenarios, because checklists are friends of humans. It reduces the cognitive load when you're going through a stressful situation. We also need to be able to detect incidents in ourselves, and that's where you want to monitor those signals. And signals can be things like, are you not sleeping anymore? Are you waking up a whole bunch in the middle of the night? Are you dreaming about work non-stop? Again, are you getting angry? Are you getting annoyed? Have your eating habits changed? You need to monitor those signals. And then you need to assess and determine the severity. So when Anna pinged me a week ago, oh, it was a pretty stressful situation. Oh, I'm going to go to Raleigh and give a keynote by myself on a talk that we normally give together. But that would be a short-lived incident, because in 15 minutes, that incident will be over. If we want to look at it as an incident, I'm actually rather happy to be here with all of you today. But we can assess that so that I can understand that that stress is actually a short-lived situation and apply the rules that need to be applied to that in my life. So you respond to an incident, and that is mobilizing the right people. So those SMEs in your life. And those SMEs are friends and family, but also doctors, therapists, whoever you need to help you through that incident so that you can resolve it and take whatever those necessary steps are to get yourself out of that critical phase. One step that people tend to forget here or to miss is recovery. And recovery can oftentimes mean taking a step back from work, maybe taking a little bit of a break off. That can be scary for folks. It might mean having to step away from something in your personal life that is causing some stress. But we need to focus on recovery so that we don't slip back into failure. And then how can we learn? So once that incident is over, getting all those SMEs that were involved together in a room to talk through this, where you're in a safe space and ideally can remove the emotion. That's one of the best ways that we can prevent these things from happening in the future, or at least understand what's going on, so that if you start crying a bunch during meetings, you know what you need to do to prevent that from getting worse. Because Eurbo, a company that actually surveys folks in the tech industry on mental health, actually, one of their surveys showed that 2 in 5 tech workers actually suffer from burnout. That's a lot of us. So we need to make sure that we've got the tools there to be able to handle it. Now, some of the things that we do in our technical systems, we have observability, right? It's the practice of understanding our systems. And we leverage telemetry data and tools and techniques to then help make our systems better and improve that and act upon those insights. Well, you can say that once a human is deployed to production, they already have observability built in. Because we have our senses. We have our systems that help us understand and observe the world around us. But sometimes those senses and those perceptions can be a little broken, whether or not it's from birth and we were just born differently, or whether or not experiences in our life have kind of tweaked our perception of things. So what should we be observing, or how do we observe those signals? Well, we live in a miraculous age now where we have all these wearables. Who is wearing some form of electric monitoring device? I could tell you what my heart rate is right now, what my oxygen is. So there's Apple Watches and Fitbits and Oura Rings. We can now get those signals from our body. We can understand if we're waking up in the middle of the night, what our sleep patterns are like. Other things that we need to keep an eye on are, what are our habits? Are those habits suddenly changing? Journaling is a great way here to kind of keep track of things. You know, maybe you're journaling and you realize that every Wednesday is a really rough Wednesday. Well, it turns out that Taco Tuesday was the night before. Maybe you ate too many tacos and it just doesn't work for you. It makes you grumpy. But being able to correlate those signals and observe them and understand how we can make our personal systems better. Because we want to be able to plan ahead. So in our technical systems, we actually talk about capacity planning, right? Capacity planning, we want to plan for the future. We want to make sure that we have the right resources there. We make sure we have enough infrastructure. We make sure we have the right on-call rotations, enough people on call, the right people on call. We've tested our systems. Ideally, we're practicing some form of chaos engineering. Well, it turns out that humans also have a maximum capacity. And do you know what that is? And there are some things, yes, way above your head, right? But that shouldn't be our maximum capacity. We should never be operating at maximum capacity, because at some point that battery is just going to drain. We need to think about that with our humans. And what can you be asking yourself? You can ask yourself, what are the things that you're valuing? What are the things that you just love doing in life? Because when you start to see some of those things dwindle away because other things are taking up that capacity, that's a warning sign. So when we talk about blamelessness, and I've mentioned postmortems before, postmortems are that opportunity after we've had an incident to sit around a table and to remove our biases, such as hindsight bias, like, well, why did they make that decision? Because obviously it led to this, when we don't have that opportunity to know that when we made the decision. Again, we want to do the same thing for our humans, because humans are going to fail. It is just part of our nature. It's unavoidable. So we want to practice blamelessness most oftentimes with ourselves. Because I think a lot of the time other people are a whole heck of a lot nicer to us than we are to our own selves. So remembering that this is just part of the human journey, that failure will occur, and how can we learn from that? You want to think about how can we move from these reactive systems to more proactive systems. So with our technical systems, we talk about what are we doing today to make our future systems better. Well, with our human systems, I like to say, what is, it's Wednesday. What is Wednesday Julie doing to make Monday Julie happier? And building that human connection really is important. We are not meant as a species to be solitary animals. Now, in the past 3 years, we've been virtual, we've had to maintain these connections via computer, and now luckily we can all be in the same room together. However you make those connections, it's very important to keep them up, because alienation of friends and family is actually one of the signs of burnout. So you want to think through, what are you doing to build that human connection? What are you doing to maintain that connection? Is it just sending off a text to somebody you haven't talked to in a year to say, hi, I was thinking about you because the news was talking about avalanches and didn't need to happen in Idaho? That's what I did to my friend Sarah, who I haven't talked to in a year, but I was like, you know what, I'm thinking about it. And it can be that easy. Other things that we want to do is define some goals. And y'all, these do not have to be massive goals. So I got this brand new Lego set. And actually, it's not even a brand new Lego set. I got it a month ago. I got Rivendell. I don't know if anybody else has seen that one. So excited. I was so excited. I was staying up until midnight so that I could get that Lego set right when it got released. I haven't even opened the box. So a small goal for me will be to build bag 1 by this time next week. And you can all hold me accountable because I'll post about it on Twitter. But that's just a small goal. So just define a goal, and then are you working towards that goal, and maybe be a little bit flexible too? Because honestly, I don't know what this weekend is going to look like, and we might have some gardening to do. So I'll be flexible, but I'm going to work on bag 1 and take some baby steps. Also, develop a personal board of directors. Again, this can be medical professionals, therapists, friends, families, bosses, current and former, people who can also help you reach your goals if they're more than building bag 1 of the original. The final concept that I want to leave you with is something called prospection. So this is a technique that positive psychology theory uses to look forward. So imagine a future with a positive outcome. That can really help you get out of those times of stress. So when I'm going through an incredibly stressful time, I like to think, okay, this is going to be in the past, and in the future, this is the outcome of all of this work. And remarkably, that can really help set your mind in that positive mindset versus that death spiral that we talked about earlier. Here's some self-care tips. Make sure you check in with yourself often. You can find the Yearbo survey at this link here. Check in on your teammates too. Remember, we're all facing that somebody might be struggling and they might not even know it. And that's actually one of the signals. If a bunch of people start coming to you asking, are you okay? What's going on? You seem to be working all night, you seem to be stressed. That's a signal that you should listen to. Unplug if you can. Stop doom scrolling all night long. Leads to terrible sleep. They say that you should turn off your electronics an hour before sleep. For me, I'm just gonna work on 5 minutes. And set deadlines, and remember, start small, be positive with yourself. Here's some resources, so I'll leave this slide up here for a moment so that you can take a picture if you need. But there's some really cool apps like Calm or Headspace. YouTube has some awesome meditation videos. Right now, I'm totally into acupuncture, by the way. That's great. Can really remove the stress. But think about what will work in your life. And it's really important that we keep these conversations going so that we can remove this stigma. I appreciate everybody who raised their hand saying they've suffered from burnout, and everybody who didn't because they didn't feel like they wanted to share. It's okay. If we can keep these conversations going, hopefully we can help each other through these times. And then finally, while this talk is about the humans, not all the images in it were created by humans, so any image with a little color bar was actually created by Dolly. And with that, I actually have a coworker. We're all humans, be kind, and it is okay to ask for help. And that's the image. There for Dolly. I have a coworker, John Vogel, here, who will also be running a meetup on May 5th from 12 to 2. Welcome to attend, and I want to thank you for your time, and I hope we have an amazing DevOps Days Raleigh.
Thank you, Julie. Oh, what's beeping?
It's a timer. I didn't even hear.
Check the oven. Thank you. One more round of applause for Julie. Thank you so much. I like that last slide about reaching out. Feel free to reach out to me online. I'm Nirmal Mehta. I'm a solutions architect at AWS, but you can find me on all the things. And if you need to talk to someone anytime, please reach out to me. There's others in this room that probably can fulfill a similar capacity. So get in touch, and if you're feeling like you're about to go in that death spiral, know that you're not alone. There's a lot of folks in this room that have gone through burnout, recovered through burnout, are in the active state of burning out, might be actually on fire. So we're all here to help each other out. And I have one question for you, Julie. Am I allowed to elect my dogs as people or participants in my personal board of directors? Oh, there we go. Oh, yeah. I can understand that. I'd like to introduce our first sponsor, Dell. Come on up.
Hello, everyone. Are you awake yet? Okay, there is some overreaction. How many people here think that Dell is just a hardware company? Thankfully, not as many hands as I thought. Yes. All right, so I am from Dell Technologies. My name is Laura Santamaria. I am a developer advocate on the DevOps DevRel team. So yes, we do DevOps. I'm not here to sell you DevOps. I'm here to talk about DevOps. So we will be having a couple talks today. I'm going to be talking about communities of practice, and then one of my coworkers, Derek, who I think is in the room somewhere. There he is, all the way in the back. Derek will be talking tomorrow about how we scaled at Dell. But just a couple things to know. Dell is here. We have a lot of chocolates. Please take them so I don't have to take them home. And we really are here to tell you that we will help you make any kind of transition for your company into more of a DevOps mindset. We will help you bring yourself to the cloud. And we have Ansible, we have Terraform, we have APIs, all kinds of different things to help you get where you need to go. But the biggest thing we're here to do is participate in our local community because we have a pretty big presence here in Raleigh. So that's it. I'm keeping it short because I think the talks are more important than hearing me pitch Dell to you. Thank you.
Thank you, Dell Technologies. Go check out their booth during our breaks. And yeah, I already had one of the chocolates. They're awesome. Never eaten a computer display before in chocolate form. So I'd like to introduce, are we ready for the next speaker? Yeah. I'd like to introduce Sarah, who is going to speak about a topic that I am personally super interested in, and that is observability. Who here is interested in observability or monitoring? Oh, it's a perfect crowd, Sarah. All the hands raised. Especially now that we need to observe our bodies and our systems, and our human systems now, right? Based on this conversation. So without further ado, let's get Sarah set up. And I was kind of reflecting on the idea that life is a long series of step threes. Who feels like that right now? Yeah, that's unfortunate, isn't it? That level of stress is not good. I think what we're going to do, I might pull out some de-stressing techniques later today. I think that would all benefit us, right? Maybe get rid of that set free feeling in the core of our stomachs, and kind of just like focus on the moment. Earlier this year, I went through all my apps on my phone. I deleted Reddit, deleted Instagram, deleted Facebook. And then I found out that I did not know what was going on in the world, and it was a state of nirvana for about 5 minutes, and then I reinstalled all those apps. No, but it was like a good, first step. You take those little steps. At AWS, I work on observability for containers, and so I like the idea of not only observing our systems, but also observing ourselves. And like using our Fitbits and our Apple Watches and other people even to have a better understanding of what we're going through personally. And so I'm going to really take that to heart, Julie. I really appreciate that. All right, we almost there? There we go. All right. One more, here we go. One more round of applause for Sarah.
Thanks for having me. I'm really excited to be here in Raleigh. I work for Telemetry Hub, which is a new platform launched by Scout APM, if you're familiar with Scout. We've got a good presence here in Raleigh. We've got a WeWork office. I am from East Tennessee, so I'm very happy to see other humans because I live in basically a cow field, so this is awesome. And thanks for joining me. I'm going to do kind of a look back on monitoring and then a look into what observability is today, and then a quick look at one of my favorite open source projects. And hopefully you'll come out of this with a little bit of interest to kind of dig deeper. That's kind of the goal. So we're going to start with why do we care? We care because, we were talking about burnout earlier. We don't want to burn out. We don't want our nights and weekends to be totally occupied with keeping things up and running, especially systems that we don't understand. We don't have access to the information we need to support them. We want to be working on things that will be moving us forward, the things we enjoy working on. Troubleshooting debugging can be fun, but it's not something we want to do all the time. It also does not make our C-levels happy. It's very expensive, and it doesn't move the company forward necessarily. It keeps you in this treading water state where you're just trying to put out fires and keep things alive, and it's not always a fun place to be in. So thinking back to where monitoring really started, it started with monolith systems. You need to know, is your system up or down, essentially, is kind of the first point, right? Are we alive? Are we not alive? When you think about kind of like V1, can people see my site or can they not? And we've evolved since then. Now there's a lot more going on, a lot more complexity. But basically, this is where we started. Are we good or are we not? Red or green? And that's really where performance monitoring came from. I'm going to date myself by saying that I had this pager at one point in my career. I don't know if anybody else is familiar with this, but yeah. I still have like anxiety dreams where I hear that tone and I wake up in a panic and I'm like, oh my God, server's full of log files. I have to do something immediately. It's just like not super fun. But anyways, this was a good way to alert people that something needed to happen, that somebody needed to do something. And it was enough. It was the right solution for the systems that we were working on at the time. We could, see trends. So latency is growing. We need to look at something. We can see load, we can see error rates, that sort of thing. It was information that we needed at the time. So why do we need anything else now? That's the answer to that question is distributed systems. So distributed systems have brought a lot of great things to our lives. All of the utilities, scalability, reliability. It's a more efficient way in a lot of cases to develop software, to release software. It's more modular. It can make onboarding new engineers easier. There's not as much to have to hold in your brain as one individual. But with that added complexity and all of those relationships across systems and across services, it's harder to monitor. You can no longer just say, are we healthy or are we not healthy? Are we up or are we down? There's a lot more to it than that now. We've also been introduced to ephemeral resources. So what happens when you're auto-scaling and shrinking your infrastructure? If something happens and where it happened is no longer there, that's a difficult thing to be able to understand and troubleshoot potentially. And again, this has brought a lot of good things. But being able to auto-scale, being able to use these ephemeral resources is awesome. But when something goes wrong, it's just a little bit harder to troubleshoot and to totally understand. So just a quick talk about metastable failure. The super fun state that a system can get into where it cannot recover, but things still look like they're okay when you're looking across your services. If you're looking at your monitors, call it like a watermelon dashboard, everything's green, but behind the scenes something is really red. And it's going to be hard to figure out what that is by just looking at a dashboard, a monitoring dashboard. Because potentially most of your services are good to go. They're sitting and waiting, but something back there has fallen down and we don't know what it is. And we didn't think to look for it, so we never set up the right kind of monitoring or the right kind of observability for that particular service. So we know that we need to step up our game when it comes to monitoring. So what do we do next, right? We've got all of our monitors in place. We feel pretty comfortable. We get paged and sometimes we don't know what to do. Like, how can we make that better? That is observability. That's where observability comes into play. And I'm gonna call it, the answer to everything. And then I'm gonna tell you that it doesn't matter if we call it observability or if we call it monitoring or if we call it advanced monitoring, semantics. But on paper, and if you Google observability in systems, what you'll see is that it's the ability to understand the internal state of the system by looking at the output. Now, one thing that I want to note is that we always talk about observability and we talk about monitoring. And you'll notice the ability on the end of observability, it's a state of being of your system. So it's not just, are we monitoring it or are we not? But it is this system designed in a way so that we can have insight into it. And that's something that I really want everybody to keep in mind. It's almost a cultural mindset. When you're building systems and when engineers are writing code, and when we're thinking about business cases and who our stakeholders are, who needs that insight and can they get it easily? So for me, this is a lot about breaking down knowledge silos so that people can have access to the information that they need to do their jobs efficiently and to not have big roadblocks in collaboration and communication. So again, monitoring, doesn't it do that? It can. So that's one of the places where this gets a little bit muddy because there's like observability tools and then there's observability as the state of being of your system. Monitoring might be enough. If you're supporting a fairly simple system, the infrastructure is pretty straightforward. You as an individual who's kind of responsible for the health of the system, you know where everything is, what's going on. You may just need monitoring. That may be enough. You may not need to go hog wild into instrumenting and collecting telemetry out of every little piece of your system and infrastructure. That could be overkill and huge waste of your time. If monitoring gives you the answers that you need, your system is observable. It doesn't matter that you haven't bought a tool called observability tool or whatever. If you can answer the questions that you will be presented of your system, it is observable. So obviously a little muddy, but again, the outcomes are what we care about here, the answers, the ability to resolve issues permanently and have the information to do that without having to rely on, prior knowledge or subject matter experts somewhere who know something because they've been at a company for 50 years. Observability isn't done. So it's not something where you're suddenly observable, you've deployed an agent and now observability is good to go. That's not how it's going to work. You want to keep evolving this as your systems and infrastructure evolve. It also doesn't have to be all or nothing. So one of the things that I hear a lot when I'm talking to people in the industry is that, we have been using these monitoring tools for my tenure at this company, and moving into this new world of observability sounds really overwhelming. I'm not ready to rip stuff out that I've spent years maintaining and implementing. It doesn't have to be all or nothing. You can introduce a little bit of observability in areas that are maybe a little bit of a black box for you. Try it out. There's a lot of different great tools and open source projects. I'll talk about one of them. But it doesn't have to be like all or nothing. You're only traditional monitoring or you're only this new modern monitoring for distributed systems. That's, I think, a bit of a misconception that can be a little bit off-putting, and it kind of makes people want to put this priority on more of a back burner instead of thinking like, we should do this now. And I would always say that the right time to start thinking about your observability strategy was yesterday. And if you didn't do it yesterday, you want to do it today. You don't want to catch yourself without the information you need and then be thinking about, okay, how do we now retrofit this into a system that wasn't architected to be transparent? So again, doesn't matter what you call it. You can call it, modern monitoring, advanced monitoring. It's really about the right tools and the right design for your team and your company. So So thinking about the origin of this term observability, I think Charity Majors from Honeycomb was the first one to start using observability to be applied to this sort of insight into the system. But it actually comes from the theory of control systems from 1960. So this is not a new idea. Originally looking at human systems, so how human beings interact with each other, a lot easier to understand the outcomes of those relationships than trying to wrap your head around all the nuance of individuals and how they interact with each other. So kind of an interesting start to this term. So if we want to be able to understand what's going on in our systems by measuring the outputs, we should just collect all the outputs possible, right? Like just get everything that our systems can produce. We're going to get it. We're going to store it somewhere. Maybe we'll organize it later. Maybe we won't. Maybe we'll think about the strategy of how we're generating that data. Maybe we won't. Maybe we'll put it in one place. Maybe not. And then when something goes wrong, oh boy, now you're sifting through a lot of data. And you can get yourself into this state where you're data rich but information poor, and that's not valuable. The time and money spent on generating, collecting, and then trying to use this data that you've amassed is not valuable. It's not the best way to do this. So, when I think about, logs obviously have great information in them, but we want to think about the strategy around it. We want to think about centralizing our telemetry data so that it's useful and we can correlate it and it makes sense to people who weren't involved in the initial creation and design. So really, when we talk about observability, again, what we want to be able to do is answer unknown unknowns, the questions that we did not think to ask. And that's where the observability kind of encompasses the monitoring. So monitoring is, these are things that we expect to potentially be problematic. We know that we want to keep an eye on a response time. We know we want to keep an eye on an error rate. Observability is going to give you some of that insight into something that you didn't know could possibly go wrong. And that helps you think about not only is your system up or is it down, but is it deployed in the best way possible? Is your infrastructure the right infrastructure and the right configuration to support your system? Are you spending a lot for resources you aren't using? That's the sort of thing that traditional monitoring might not be able to answer for you. And thinking about reliability, if everything's green, but your users are having a weird experience, it's still not good. It doesn't matter. If somebody says something's going wrong and you're like, well, not on my dashboard, that's not a good answer. And that's not something that, is going to solve the problems for your customers. So again, can I just buy a tool? You can. There's a lot of observability tools out there. My company is one of them. I'm sure that your inboxes are inundated with, observability. You need observability. You need this observability tool for logging. You need this observability tool for your metrics. You need this observability tool for, X, Y, Z. But I just want to emphasize that it's an investment. It's going to take some work, and you don't need to buy, the biggest and most expensive thing if that's not what your company needs. I think that sometimes we get a little bit of pressure from potentially our higher ups or somebody who had a good experience with the tool at one point and they're like, oh, I used this at my last company. We're going to use it here without really thinking about whether or not it's applicable. It could be too expensive. It could be too much to maintain and implement. You could end up with, a huge invoice for something that nobody uses because it hasn't been implemented well, or people don't understand it, or we never got around to finishing the configuration of it. I'm sure we've all seen tools like that. So just be very pragmatic when you're thinking about how you want to achieve observability within your systems and applications. So again, what do we care about this? So I think about an experience at a company that I worked at where we had a legacy service that only one person understood. He'd been at the company for 20 years. The rest of us had been there for like 5 or fewer. And anytime anything went wrong with that service or request to that service, the answer was, go ask George. And if George wasn't available, it would restart the service. So that's not a great way to feel confident about the reliability. Like every time I restarted that service, I was like, please God, let it come back up. Like, what am I gonna do if it doesn't come back up? Like, I have no idea how to actually fix this or what it's actually doing. It's a technology that I do not know. All I know is that my runbook says, when this happens, call George. And if not George, restart service. Not great, right? What I needed was the ability to get some information. And that would give me a place to at least try to make some educated decisions about how I could potentially resolve it. The best thing would have been for somebody to fix it so that it would have stopped doing that. But beyond that, just being able to have some information about it would have been really, really useful. It would have meant that maybe when I came to George, I had some idea of what was going wrong instead of just being like, that thing is happening, that happens sometimes, to fix it. I mean, not a fun place for him to be in, job security, I suppose, but I think we've all ended up in that place where we're supporting one thing, where we're the only one who knows it. It's not fun, and it's not a good place when you're trying to support something at 3 a.m. and something's fallen over. The other reason we should care about this is for better collaboration. So I'm looking at this from a product management perspective now, and I see in the observability approach that we've used at Telemetry Hub, I have a lot more information available to me now than I did 15 years ago when I was actually supporting systems. And for me, this is what I wanted and what I needed. You know, I don't have to go ask somebody for access to data to be able to answer questions about my system. I have, you know, the ability to drill deeply into insights about our customers, our applications, our infrastructure, and it's all in one place, and it is designed in a way that gives me information that I need as a product manager, but also is deep enough for our engineering team to use to make improvements and kind of plan what we're going to be doing as an organization. I really think that the democratization of data across an organization can really make everybody's lives better. You know, it can let your support team, your frontline support team, have a better starting point for troubleshooting issues. It'll let your product management team understand why you might need to invest in technical debt or spend time working on your infrastructure. You know, it really just kind of gets you past the, well, this is a fact because I've said it. You have data to back it up. And in product management, everybody is always talking about data-driven decisions. They're usually talking about usage analytics, but for me, this is the sort of data that I also want to have available when I'm making decisions. And I know that my engineering team feels the same way. And along with that, I mean, the increased context is something that is just kind of invaluable when you're thinking about how your teams communicate with each other. I mean, a lot of times there's a bit of a push and pull between like product and engineering or engineering and design, and it's a natural tension that I think is good because it makes you build the best thing possible. But without the context of like, how do all of these things relate to each other, it's really easy to get frustrated. I don't know if anybody's seen this YouTube video, but it's amazing. Watch it. If you just Google comedy, microservices comedy, it's a PM, and I've been in his shoes listening to an engineer explain all of the relationships of this system and why they can't do the thing the PM wants. And the PM's like, just do the thing. It's such a simple thing, you know? And I've been guilty of that. And without being able to understand what's happening, your PM never really gets it, you know? Your C-level doesn't get it. They don't understand. Like, on a piece of paper, it's like, you know, can't you just sort those 5 million rows? Like, I can see them all. I can page through them. Why can't I sort them by any particular field? And trying to explain why that is so difficult is just a lost cause. But if you had data that you could show and they could have some insight into that system, it would be such a better conversation. When you're trying to advocate for something that you want to do within your system and you don't have data to back it up, you know, good luck. It can be really, really tricky. So having this data available and not just kind of like locked away in an ivory tower is a really great way to kind of bring everybody onto the same page and not leave anybody feeling like they're in the dark. I know as a product manager, I don't like feeling like I'm in the dark. I like to know what's going on. I know that my managers feel the same way, and everybody in my company has access to our application insight, and it's really made things a lot faster and easier and more efficient, in my opinion. And this will help you reduce your mean time to understanding. I'm not saying resolution, overall it will, but this will get you to the point of being able to fix something faster. You're not going to be spending a lot of time, digging through log files, asking people what happened last time, this sort of thing. If you have better information available to you, you can understand the problem quicker and spend less time sleuthing, throwing hypotheses at the wall, looking back through Slack to see if anybody's ever seen this happen before, that sort of thing. And that's great, right? Like, we've all been in a place where we're like, oh man, I think this happened last year. Let me see what I can find. Even better if I just have it right in front of my face and I can see what's going on and I can work to resolve it right now. And then think about resolving it permanently so that it doesn't happen again. So when you do get that 3 a.m. page, maybe the next day, after you've slept it off and you're no longer frustrated by that call, think about whether or not you can answer these questions. If you can't answer these questions, your system may not be transparent enough. So who is being impacted? If something goes wrong and I get paged, can I tell who that cares about this is being impacted? Is it my largest customer who just onboarded 500 people halfway across the world and that caused load issues and this is a big deal and we need to think about it now? Or is it one of my offshore QA testers doing some testing that's caused some weirdness and I got paged by it and I don't care? If you don't know that, you have to go into that mode of we need to fix this now. You don't need to fix everything now. You don't need to always address everything that wakes you up at 3 o'clock in the morning. So you have to know the severity of it to make that decision. You have to know who's impacted. You have to know how serious it is. Otherwise, you can't make that decision, and your only other choice is to try to address it immediately. You have the information to tell you what you need to do to resolve the issue. Where is the problem? In my distributed system, where is it? Is it in a particular region? Is it in a particular cluster or pod? Is it localized geographically some way? Looking at aggregated monitoring isn't going to tell you that. And then again, when did these issues start? Why do we end up in this stage? It's information that you need to know to not only resolve the issue, but make sure it doesn't continue to happen. So I'm going to talk about the 3 pillars of observability. Again, these are a little more tactical and a little less about making your system transparent and keeping that mentality. But these are 3 pieces of telemetry that can help you build a more transparent system. So metrics, people are very familiar with. Statistical information in aggregate. They're cheap to store, which is wonderful. If you want to be able to look back, they're not expensive to store and work with. The problem with metrics is that when you have something that you want to drill down on, that underlying data is gone, and it's too late unless you've collected it somewhere else. So a great way to page somebody and let them know that something's gone wrong, but not a great way to have that really granular insight of what's happening, that low-level look at what's happening. The distributed traces are kind of the golden child of observability when we're thinking about this modern idea of being able to trace a request from start to finish. And this differs from traditional detailed tracing because it shows you all of the hops across your entire infrastructure of a request from start to finish. So instead of saying I have a trace of what this particular service did, or I have some information about what this service is doing, I can understand that this service used this resource on this particular pod, made this request, came back with this result, and I can tie it all back in a nice look at the hierarchy of all of those requests that respond along the way and what happened. So not inexpensive, I think when we think about observability, a lot of people think about the cost, and that's very valid. It is a lot of data to be able to do this sort of thing, but it is very valuable when you're trying to diagnose and troubleshoot. So this is a quick look at the platform that I work on, Telemetry Hub, but just a look at the hierarchical view of the span data that makes up the trace. The nice thing about it, you can kind of see here, this is demo data from the Open Telemetry project, but we're moving across resources, we're moving across technologies. When you drill into the span, you can see some really granular data. In this example, it's an e-commerce platform, and you can even drill down as far as to see the product name. So when you're able to pivot on that kind of data, it's a lot easier to troubleshoot reliability or one-off issues. And then logs. I had ChatGPT write this for me. I asked what it was like to use logs to try to troubleshoot active production issues, and this is what it said, and I thought it was kind of funny. Although it also sort of looks like a t-shirt that Facebook would try to sell you. But I left it in there anyways because it's kind of funny. I've spent a lot of time trying to use logs to troubleshoot and resolve issues, and it sucks, right? Like, you know the data's in there somewhere, but it's so time consuming and can be so frustrating. And you may not have access to the logs. You might have to ask somebody else, or it might be in another part of the system, or they could be gone, you know, it can just be a frustrating experience. So having them in one place where they're usable is really important. So just a quick recap of that. Don't just amass data. Don't be data rich, knowledge poor. Be able to answer the right questions to support your system. You can waste a lot of money by buying tools and storing data without having a strategy. You're going to get sick of all the different tools that you try out. There's a lot of them, you know, and you want to be thinking about the right way to do it. And just remember that your team and your system should dictate the approach that you take. So don't just do what you heard somebody else do. Don't do what your CTO said you did at the last company. You know, think about what will benefit your team and the way you like to work together. So now in the last 5 minutes, I'm just going to talk a little bit about OpenTelemetry. It's a project that I love and my company's really bought in on, and I really think is going to be standardizing the way telemetry data is collected in the future. I just think this is the future of monitoring. So just a little bit about OpenTelemetry. Visit their website. It's awesome. There's tons of data on there. There's samples and instrumentation information. They have a super active community Slack. CNCF Slack has lots of hotel channels. But this project is the second most active CNCF project after Kubernetes. So that should give you some sense of the kind of traction that it's getting. Lots of support for this project in cloud platforms already. Lots of big companies bought in on it. It can be very simple to use. It's obviously vendor agnostic, so you can do what you want with it in the way that you want to, and it can grow with you, which I think is an amazing thing. So just a look at what you get with OpenTelemetry. Again, it's about standardizing. So to be able to look at signal data that's coming from different sources and having it in the same structure gives you the ability to correlate things in a way that we haven't been able to do in the past. And for me, that's been my big eye-opener. You know, I can understand what generated a particular log when I'm checking out an error or something like that. And in the past, it was a lot about I'm correlating it because of the time it happened or some information that I have in my head. And this really changes that. So the components of OpenTelemetry, you know, cross-language. So you take your favorite language, and there's probably already support for it. Your favorite technology, probably already support for it. If not, there's ways to make it work. And also very active SIG groups, so you can contribute. Just a quick look at what it would take to do auto instrumentation on a Python application. This is again from my company's docs, but just to kind of show you, it doesn't have to be overwhelming. You know, you can start with just a little bit and then way deeper as you go. The OpenTelemetry collector is a very powerful part of the OpenTelemetry project. It does kind of your data processing, so it will let you, you can stream all of your data through it, you can export it to multiple backends, like my company, or keep it in-house in your infrastructure. And there's different ways that you can deploy it to also automatically collect infrastructure information. So we have it deployed in a Kubernetes cluster, and just by doing that, we get information about all of the different pods. So all that metric data automatically captured for us, and we see it in our front end, which is just awesome. So again, just instrumenting something isn't what makes it valuable. So you have to think about what you're going to do with that data. You also want to think about your strategy for what you're instrumenting and how you can do manual instrumentation or auto instrumentation. But OpenTelemetry doesn't come with a strategy for storing or visualizing that data. So those are the things that you have to think about when you want to use it. So great tools out there already, lots of big vendors supporting it, and then also lots of great open source tools that you can use without having to sign up for a service. So I'm going to do one quick kind of real world analogy. I spent a lot of time trying to explain to my husband and my parents what it is I do and what we talk about. And this has been the best way for me to explain it to them in a way where like they sort of get it, I think. And I stole this from my engineering manager with his permission because I felt like it was a really great way to kind of spell this out for people who maybe didn't have, didn't understand why this is important. So if you're in your kitchen and you're cooking dinner for yourself or your family, you know all of the pieces that have gone into that meal, right? Like if it is burnt, you know it's because the heat was too high and you did that, or something's going wrong with your oven or whatever. But you have purview into everything that's happening. You can potentially know how cold your fridge was, you know when the food was purchased, all of that. This is a very observable system. It's small, and you as an individual human, you know all of it. So when you think about the restaurant industry, and why I no longer work in the restaurant industry, because it's super stressful, there's a lot going on. And between the time that your server takes an order, it flows through all the stations in the kitchen, everything's fired, it ends up back on the table. If something's gone wrong, it is really hard to know what happened and what went wrong. And for me, that really paints a picture of when you need observability. Not great observability in any kitchen that I've ever worked in, which is why I won't do it again. But, you know, this is where you need that insight. Like there's multiple steps, multiple people involved. You think of these different stations of services. If nobody's overseeing them, things can just keep going wrong. And if you've ever been in the weeds, you know that it just keeps piling up and piling up and piling up. And if you're not addressing the issues, you end up in a really unfortunate state that is not a good place to be working in. So one thing I just want you to take away, again, is that observability or enhanced monitoring or whatever you want to call it, it doesn't matter. Just think about whether or not you have the information you need to support your system. You don't want to be out there in the middle of the night feeling like a lonely person on an island without support. And that data and the way that you collect that data can be what makes your day a little bit better. Thank you.
All right, thank you so much, Sarah. +1 on the open telemetry. Another round of applause for Sarah. So a couple quick announcements. We have workshops starting at I think 2:30 in rooms 4 and 6. That's to your left in that hallway. I believe it's one on Terraform and one on Service Mesh. So check those out. And then we also have the Open Spaces board is still open. I don't see any more subjects there. We're going to take a quick break right now. So if you are interested in putting something on the board, maybe even open telemetry, which is +1 to an awesome project. That might be a good topic. But whatever you want to talk about in open spaces, please come up to the board. And we'll come back at 10:40. So you got a quick break.
Don't worry, don't worry.
Close, man.
Cool. Yeah, so there's someone go out. These doors. I don't want to walk in the middle of work session. Good, good.
Oh, they are?
How's it going, Marilla?
Good, how are you?
Oh, pretty good.
All right, everyone ready to kick this off again? Come on back in. Only one. Did you all get some, I think I see two more things on the open spaces board. Again, if you have a topic that you'd like to talk with other folks about, please come on up and put it on the board. Some more ones, some more topics there. Is everyone copied up? Yeah. Does anyone want to see Cheerwine next time? Yeah. Are they willing to pay a lot more in ticket prices for that? No, I don't know why we can never get Cheerwine at the NC State Conference Center. That seems really odd. Oh, I almost forgot. I asked ChatGPT to write me a poem about metastable failures. Y'all want to hear it? Well, you're going to hear it. Metastable failures, oh so rare, a delicate balance in the air. One wrong move, one tiny nudge, and the system crashes with a grudge. That's why you need a thermal board. Not bad, right? All right. Ready here?
Yeah, you want to get that selfie now?
Yes. Let's go. All right. Without further ado, I'd like a huge round of applause for Marino.
Hello, everyone. Welcome to DevOpsDays Raleigh. I just gotta say, I feel so awesome being here because about a year ago, I did my first DevOps Day at Raleigh as a dev role. It was like the first ever DevOps Days, and I was like, to come back here and be able to speak, super surreal, super awesome. So thanks for having me again. So my talk today is a little bit, it's going to be a little bit technical. Unfortunately, I couldn't get my demo over this morning. I was messing around with it, and I'm like, you know what? Let's just talk through some of the key components of what you would do with edge computing. And I'm sure a lot of you have heard the Chick-fil-A story and how they achieve edge computing through Kubernetes. If you haven't, I'll tell you a little bit about it and why they approach it. A couple of other things for you to consider. I come from a networking background, so there are a lot of networking challenges when it comes to edge computing. We'll talk a little bit more about that and we'll figure out what the right fit is for that network stack and deploy the edge. Come on, work. There we go. Oh, too far ahead. Okay, so yeah, that's me. One thing I will say is while I am a platform advocate at Solo, I do a number of other things for the community. I'm running an event called Food Club that's happening in Toronto, so please go check it out. I'd love for y'all to come by too. But I'm also part of an ambassador program for AnyHub. And part of the reason I decided to join that, it's a smaller community, but it's focused entirely on open source collaboration and community, and then code afterwards. And the main reason I decided to join that community was because there are a lot of individuals there that want to grow their career, they want to get into the world of cloud native and DevOps. And I'm not a developer, but I lived a technical life, and so there are a lot of things that I can relate. And I felt like, okay, let's go join that community and be a part of it and see what we can do to lift everyone else up. So I'll recommend you go check it out too and see what goes on. With respect to edge computing, it's a very interesting environment and setup, but that's not the right slide. Oh, that is the right slide. Okay. So when it comes to setting up the edge, there are a lot of different considerations you have to think about. The first and foremost consideration is the why. Why am I even considering using edge computing? There are a variety of factors. You might think about the fact that I have these high-performing applications that are susceptible to latency issues, so I'd rather have them more located to whoever's accessing them. I might have a situation where I want to take an application and distribute it across multiple edge locations. And maybe, and sorry for the folks that like cloud, maybe I want to get away from the cloud and run my own cloud in a very highly distributed environment. But there are so many different challenges to consider. One of them I'm going to talk deeply about, and it really falls into the networking aspect of it. But there are other challenges too, like people. Do you have the right expertise to be able to build out this edge computing? Do you know what you actually want in your edge stack? Do you know the kinds of applications you're going to run? Do you know how much it's going to cost you in terms of procuring hardware, lead times, installation, and then having to make sure that things go well before you go live? And so much more. And then there's the whole other side of it is, okay, we have our edge up and running. How do we see what's going on? How do we know that this is still the right fit? And if we can continue to add or iterate on top of our edge. So what does that edge actually look like? Come on. Change on me. There. That's way too. This is the slide I missed. I was wondering where that slide went. Okay, so what is edge computing? I felt like I missed that slide. Go. So edge computing can mean a lot of different things. How many of you run edge computing today? Y'all are lying to me. You can't come to this conference and tell me you don't have Docker installed on your laptops or your MacBooks, because that is effectively edge computing. Except it's on your system. You're not exposing it to anyone. No one can mess around with it or access whatever app you deployed. But on the other hand, the principles are still the same. You're providing CPU, memory, disk, network access, and a lot of other capabilities so that you can run that app, except your laptop isn't meant to be production oriented. It's not meant to be deployed in production like the way you would with servers. Now, when we think about the edge though, we're not thinking about deploying these large rack servers there. We're thinking about something as small as we possibly can. How many of you have played with Nux before? Or the Jetson Nanos? Yeah, they're pretty interesting devices, very tiny, pack a lot of power. They can do a lot, but with the innovations that we've seen in cloud native, with containerization, and with what Kubernetes has done, well, Kubernetes and the edge are the perfect fit. It's like marrying these two amazing things together, and now you can pretty much do whatever you want. So let's get ahead to this next slide. Let's think about some of those challenges, though, when it comes to those edges. I deploy an edge at, let's say, a branch location, or a retail store, or even in my basement, and you're running a bunch of apps, and you start to think about what do I need to do to be able to see everything that's going on? I mean, there are open source tools out there like Prometheus and Grafana that give you a glimpse of what's going on, but you need something a little bit more larger scale, especially when you're operating, hundreds of edges in different locations. You need to know about those changing network conditions. What happens when you lose a circuit? How do you fail over to another circuit? Is it automated? Are you using something like SD-WAN to make that possible? Do you have systems in place to be able to accommodate for those failures? You lose an edge in another location, take on that traffic. And so observability is like very, very critical. And that previous talk by Sarah is very fitting even for the edge. Sarah also mentioned at the very end of her presentation around tracing. Tracing is also very important too, because even though you have applications, very small ones running in containers that run at the edge, they may be talking to other applications across other edges too. And so that tracing element really helps because it can help you determine, are my applications geographically co-located so that they perform better? Or do I have an application or an instance that's hopping across the pond to make an API call to an edge that lives somewhere in Europe, which might not be the best fit, might not be the best approach altogether. So we need to see what's going on. And the tools that we have at our disposal are wide-reaching. But the reality is, there are various tools that you can take and choose. You just have to really think about what's necessary for your edge and how much you can actually deploy onto that edge. Because the other considerations come about. Think about the fact that you have, let's say, two of these NUCs that have, 8 CPUs combined and 128 gigs of RAM, and maybe 2 terabytes of disk. What can you do with that? And oh, by the way, you're limited by your circuits. You have 2 10 meg circuits. What can you do with that? I mean, there's a lot you can do, especially if you decide, I'll process a lot of my data locally and then I'll batch transfer it when I need to, which does help. There we go. The other element too to consider is security. So security is very important in the sense that you have different applications that might be deployed to these edges. And then you also have to consider where you're pulling these applications from. Have they been built appropriately, especially if you're pulling them off the shelf? Are they keeping in line with any sort of vulnerabilities that come out so that you can change as that vulnerability has been patched? And then there's the element of access. Who has physical access to these boxes? Do you leave them out in the open so that anyone can just walk up to these edges and then power them down at will, and then now you have problems? Or do you lock that down in a little room that no one has access to? And that's just the physical side of it. What about accessing the operating systems? What about accessing the clusters themselves, the applications that live on them? Maybe you don't want individuals to be able to access that. You'd rather have API keys and tokens that allow you to access Git repos instead. And so you pass in your changes that way, and then it gets reflected GitOps style. But then there's also the element of, okay, if we have these different applications talking to each other, how do we provide, I hate to use this word, zero trust. Such a marketing term, I know. But how do you provide that layer of trust between all of those different services, especially when you have cross-edge communications going on? What's the next slide? Where is it? So before we dig into that, there's already an excellent solution out there called KubeEdge that addresses a lot of the ways that you can deploy your applications to the edge. It addresses this element of, okay, I want the experience of Kubernetes running inside of my edge without actually running Kubernetes. Now, in a lot of scenarios, this might be great if you have HTTP-based or MQTT-based applications and nothing more. And the reality is the edge is not meant to, especially with KubeEdge, is not meant to be a full-blown Kubernetes cluster. So how this all works is you deploy a control plane, a Kubernetes control plane somewhere else, whether it be in your own data center or in the cloud. And then your edge locations deploy KubeEdge, which actually isn't Kubernetes. It can talk to Kubernetes and understand instructions from it, but it uses its own stack. And while that's great, while it's very locked down and gives you all what you need to be able to run an application on top of this, it's not the same. I mean, you still have access to a pod, but then you actually close yourself off to being able to use other tools in the cloud native ecosystem. Primarily because this is not a native Kubernetes system. You're actually using additional components like EdgeD and EdgeHub to be able to facilitate how this all works. So in a lot of ways, this might be great to start, but once you start finding out that you need much more Kubernetes flexibility is where you'll start to realize something like Kind, K3Ds, even full-blown Kubernetes might be a much more better fit. But this is not the real true problem that we're experiencing here. I mean, it's easy enough to just deploy a single nut with Ubuntu on top of it, deploy Docker, maybe even deploy KVM, and then you can do both containers and VMs at the same time. The bigger challenge is the networking. And the reason why I bring that up is because there's so many aspects and facets of networking, like I kind of previously alluded to before. And you have to consider your circuits. Are you going to have a single circuit? You're going to have redundancy. You're going to have bonding so that you have access to all that bandwidth. Are you going to have the right routing in place so that if you have a failure in one location, you can physically route to another location? And then there's the element of DNS, and then, oh, by the way, how do we make sure that these networks stay online? What happens when they go offline? There's so much we have to consider here. So we have to think about that right network stack. The right network stack actually is comprised of pretty much anything, but this is just much more opinionated from my lens. So you're going to need some physical hardware or access to a cloud environment. You're going to need access to some sort of virtual networking. And what's interesting is the SDN layer, the software-defined networking layer, is always going to be important. By the way, software-defined networking is the evolution of physical networking, where you can build many, many networks on top of your physical ones. But then when you take it a step further, that's where we see container networking. So you've got your physical stack, you've got your virtual stack, and then you realize you need a cloud-native stack on top of that. And so you deploy a flavor of Kubernetes, you deploy a CNI, maybe something like Cilium, and then you deploy the Istio service mesh on top. Now, there's one thing to consider here. When you think about a CNI, container networking interface, it's like a switch, a network switch for all of your containers to have a layer to communicate across. But there is not so much intelligence at that layer. You have to start thinking about higher levels or higher layers. The HTTP layer is very resourceful in a lot of ways. And so this is where a service mesh really comes in to provide a lot of value. And so when you think about all these edge locations being connected to each other, it's great that you can set up something like WireGuard to provide end-to-end connectivity between all of your edge locations so that they can kind of have a full mesh, much like you would with a VPN. But then when you're starting to address elements of your containers that need to talk across different locations and elements of authorization, authentication, and even encryption in line of those containers and their communication, you can't just achieve that with your physical and your virtual networks. That's why a service mesh exists. So for those that run production environments, do you currently use a service mesh today? Who wants to tell me why they use a service mesh? I'm going to pick on the guy from ChainGuard. All right, it's already there. Why wouldn't you? Okay, and that's a valid answer, because why wouldn't you use a service mesh? It actually completes the layer of networking that you need. But why you actually would use a service mesh is most meshes out there provide this functionality called the sidecar. That sidecar kind of acts like a router or a proxy on behalf of that small container. But the reality is, when you try to deploy many, many of these, especially at the edge, you run out of memory, you run out of CPU. And so now you have to compete with a sidecar versus an actual application that's serving up data or serving up responses. So how do we get around this? Enter ambient mesh. So there were a lot of developments in the last year around the Istio service mesh. I mean, it's CNCF in a very, very quick manner, but we also needed to address other workloads or other styles of workloads. Think about server send first protocols or systems out there that actually don't benefit from having a router right in front of it and would rather just be able to freely communicate. So while you have Istio, a service mesh, and others like it, like Linkerd and many, many others that actually provide the sidecar functionality, that sidecar again does telemetry, it provides encryption via MTLS, and it even provides the HTTP routing. But if we want to save on resources, we need something a little bit lighter weight. So, if we drop the sidecars, what do we have? Well, we have ambient mesh. So ambient mesh is actually just another mode of Istio that offers sidecarless. And that sidecarless approach really means that a lot of that sidecar functionality shifts away from the actual app and lives more at the node level. So you're consuming less resources, you're still providing the same experience of a service mesh. You can't have service-to-service connectivity and discovery across multiple environments. What actually changes? Well, yeah, you're saving on CPU and memory, and there is some functionality change as well from the sense of your sidecar is no longer present, and if that's shifted elsewhere to something called the Z-tunnel and the waypoint proxy, well, how is this different than our traditional routing? Like, hey, we just layered or tiered our routing. Well, what ended up happening was that Envoy proxy that we used for the sidecar, we decided to rebuild it just to provide functionality. And we did this with Rust. The primary reason for this was to be able to consume less resources and memory and just be a lot more efficient in how Z-tunnel assumes identity of a workload, how it goes out to process and create tunnels across the other Z-tunnels, which is a very, very deep concept to discuss. But it's actually the reason why we're here. So if you think about networking back about 10 years ago and we needed to connect up various sites, what did we use? We used maybe a private network that our service providers gave us, L2 VPNs, but if we didn't have enough budget, maybe we decided to use something like IPsec. But we just went back in time, brought those concepts right back into ambient mesh. Let me tell you why. So as I said, ambient mesh takes that Envoy proxy and slims it down for the sake and purpose of providing layer 4 and MTLS. But if we take that approach and now slim down the amount of resources, we have more room to run other applications at our edge. But this is not the key interesting aspect of it. It really comes down to, where's that next slide? There we go. It really comes down to, what does this really look like at scale? So with some more innovation and some of the work that Solo has put in, what they decided to do was create a double H-phone setup. So I'll talk about H-phone in a second. But how many of you remember GRE over IPsec? Yes, well, a few of you. So it was a mechanism to allow you to tunnel, or double tunnel. One tunnel would provide encryption, and the other tunnel will actually allow you to trade routing information. So you can create much more of a fabric, an end-to-end fabric across these various sites. Well, that's exactly what ambient mesh did. We did a tunnel and a tunnel, another tunnel and another tunnel. And the primary reason for that is because we needed a way to maintain identity and encryption end-to-end. So let me back up a bit and explain the architecture of ambient mesh. So you still have a control plane, much like Istio did, that communicates with the Kubernetes API to understand CRDs and translate them directly into resources that Kubernetes understands. But then there are two additional components that Istio pumps out. One is called the Z-tunnel that I mentioned, which handles layer 4 and MTLS connectivity, and then the waypoint proxy, which does a lot of layer 7 authorization and any sort of additional layer 7 functionality that you might need. You need some telemetry data, then you can use the waypoint proxy for that. And when we just look at the Z-tunnels themselves, they are effectively our data center routers. If we treat every single cluster as a data center on its own, that Z-tunnel pod, which acts like a router, is effectively tunneling using very similar concepts across to other locations and other domains. So how we make this work with ambient mesh is very interesting through that double H bone. If you actually see in my little diagram there, you see that book info is an application that's running. Let's assume for a second that book info is split up into multiple different pieces and is deployed across multiple different edges. Now, how do we know where to get to these services? How do we find that out? Well, you normally use Istio virtual services routing to be able to find that out, and then you have your routing rules in place, and then you know how to go where you need to go. But then how do you address the double H-bone encapsulation component? So in Istio, there's something called the East-West gateway. The East-West gateway actually had to be slightly engineered a little bit more to understand and terminate the H-bone protocol, which is just a tunneling protocol, nothing special. If you've ever heard of VXLAN or Geneve, that's effectively all it is. Now, we actually have to be able to terminate somewhere else. So if I have traffic that goes from my, let's say my details page to my reviews page, which lives in that secondary cluster on a totally different network, what I need to make sure of is that I tunnel from my Z tunnel, which is impersonating the identity of service A, and that terminates at the East-West gateway, which then terminates the additional underneath tunnel or that secondary tunnel at the destination Z tunnel location. I know it seems a little confusing, but the reason for this is so that identity is maintained. And the reason why we have to do this is in previous versions of Istio, you could actually DDoS your pods. And that's something that is a security risk. You can DDoS your pods if you didn't have that secondary tunnel in place, primarily because you could have anyone that would establish an H-bone tunnel and then ultimately assume or pretend to be another pod and then effectively compromise your environment. And that's something that we didn't want. So to work around that, yes, there's double encapsulation. Now let's look at it a little bit more deeply so you can kind of understand what this truly means. I'm just waiting for the slide to change. This clicker's so slow. Okay, I just have to manage it. So this is how it visually looks, right? If you can actually, I wish there was a laser pointer here. Maybe there is. Is there? No, it doesn't show up. No, not going to happen. All right. So you have these different services across these two different networks, two different clusters. Now, service A wants to talk to service B. How does it know how to get there? Well, there's a couple of things that go on. We have to provide some level of service discovery. So this first cluster will have to go. Why is this not working? Oh, there we go. We'll have to, hang it. So like just hold it up. There we go. Okay, all right. Okay, so service A needs to talk to service B. What actually happens is service A, because it's co-located on the same node as the Z tunnel pod, will send its traffic there. Z tunnel will impersonate the identity of service A. So when it actually has to head over to the east-west gateway on cluster 2 over network B, it actually needs to communicate with that east-west gateway there and terminate, but it needs to prove its identity. So it's proving it's the identity of service A, which is fine. And that's okay because of the service discovery that's going on behind the scenes. Now, what ends up happening is that east-west gateway on network 2 will terminate another tunnel for that Z tunnel on that destination node or destination cluster. And then effectively that traffic gets unencrypted and goes right to the service itself. But this only works if you have that double encapsulation. Now, HBone, by the way, stands for the HTTP-based overlay network encapsulation. Again, if you want to go read about it, there's some Istio documentation on it. In fact, if you start reading that documentation and go look at the code, you'll start to realize it is using Geneve under the hood or VXLAN under the hood. And that's just because why reinvent the wheel when it's already there, right? So what happens when you have to do this at scale, when you have to do edge computing at scale? How does that look from the platform engineering lens? How many different networks do you want to have to manage there? How many different clusters do you want to have to sit there and deal with? And so there are approaches out there that you can take. You can do this all by hand using GitOps. And quite honestly, that can take you a bit of time. You can take tooling out there from various providers that give you a platform to be able to build out your environments. But if you're looking at it from the lens of application networking, this is where Solo kicks in. Solo's Blue platform effectively has their single set of CRDs that translate directly to Kubernetes and Istio. So you're pushing out one set of configurations, and that's applied to wherever you want to, especially when it comes to multiple edge locations. And this is perfect for edge locations because you're going to have 1,000 of them, much like Chick-fil-A does. And you're going to have to realize that it's not easy to sit there and manage network policy, authorization policy, your routing rules, your observability, and even your authentication across these different locations. So something like Blue Platform might be the right fit for you. That being said, let's figure out what my next slide is. That being said, let's think about some of these edge computing use cases. So you're seeing this today. You're seeing smart cities starting to pop up. You're seeing how edge computing has been heavily influenced in the healthcare industry because if I can have localized compute, higher processing power, I can store things, let's say at a very small doctor's office, but still get that full effect of what I get in the cloud. It's a perfect fit. We're seeing this move into the world of IoT. We're seeing how all these different, let's say, delivery trucks, UPS, FedEx, are starting to embrace edge computing a lot more, primarily because they see the value in being able to track where their vehicles are, what's going on with their vehicles, if there are any sort of issues with the way they need to get to their destination. You're also seeing how edge computing is impacting traffic systems so that you can have a better flow of all your vehicles moving around. Agriculture, another wonderful area where edge computing is being heavily used. To understand the climate, the temperature, and when it's going to rain is really impactful for a lot of farmers out there. Like, hey, now I can plan better in terms of when I can harvest. So there are a lot of different use cases that are starting to pop up in the world of edge computing, and then you start to realize there's opportunity here. There are areas that are left untouched, untapped, and we need to dig in a little bit further. And this is why service mesh and the network stack I described earlier is the best fit. So I want to end here and say, if you are ready to embrace edge computing, I highly suggest you check out a couple of books. There's two. The first book is Edge Computing Systems with Kubernetes by Sergio Mendes. He wrote this book. It's based off of K3s and uses Linkerd, and that's fine because a lot of those principles are highly transferable to using Istio and service mesh and full-blown Kubernetes. But the book lays out a lot of important details as to how you would approach it. It lays out a lot of details as to problems you would want to solve. It lays out the details around how you achieve observability and security. And so finally, when you think about, okay, I've got my edge computing solution figured out, how do I address the networking? Then you can dig into ambient mesh. So if you have any questions about edge computing, don't ask me now, ask me at lunchtime. I want to thank you all for your time. Take care, enjoy the rest of DevOps days.
Thank you so much, Marino. I think I'm going to find all those old Raspberry Pis now and make my edges sharp. So another round of applause for Marino. All right. Do we have the sponsor remarks, our next sponsor remarks from C Prime? All right, come on up, Knox. So who here has, I think Marino asked, how many folks have like Nooks or NVIDIA Jetson boards at home? Maybe in a closet somewhere? Are you all actively using them? All right. Well, now you have it. Now you can use them for something. Check out the ambient mesh on your, dusty Knox. And that's a way to introduce Chris Knox.
Oh, thanks for that awesome tee-up, Maribel. You're the best MC ever. I'm in charge of this timer, so I'm going to give myself 25 minutes. No, that's not really funny. C Prime, what does C Prime do? C Prime helps organize DevOpsDays Raleigh, for one thing, which we're really proud of. This is amazingly it's our 8th year doing this. So we're pretty proud of that. From a sponsor standpoint, I guess I'm supposed to pitch y'all. Pitch C Prime. What can I pitch? Yeah, I'll tell you what I'll pitch. C Prime provides expertise. That really is at the heart of everything we do. C Prime is a consulting firm. Consulting can mean all kinds of things, right? So it means that we may compete with Accenture, who backs up truckloads of MBAs to crunch your numbers. Whereas what CPRIME would do as an alternative to that is perhaps provide you with one senior technical agility engineering expert who has been in the trenches in large environments for many decades and can help guide your technical teams towards more continuous release, just as an example. CPRIME also teaches a lot of classes. So a lot of the tooling that is associated with DevOps and technical agility. We have hands-on workshops for teams and engineers. Another thing that CPRIME's experts do, which I'm particularly proud of, is in addition to this extensive technical expertise that they can come and provide you as technical consultants, they've also learned how to navigate the, I suppose what you might call the layers of management that often make things difficult when you're trying to enact change in a large, tangly, gnarly technical environment. So pretty hard to do. It takes some diplomacy while at the same time requiring significant engineering chops. So those are pretty special consultants. So I'm really proud to work for CPRIME, and I'm really proud of the type of expertise that we offer. If you or your teams need a class or a workshop, either on human factors or enacting change, becoming a change agent, managing up, helping leadership or people who are in some other team somewhere else jive with your teams better, sort of political stuff like that. Our consultants are really good at that. But if your teams would just like to spend 2 days in a really intensive lab-driven Terraform environment so you can help manage your cloud infrastructure, then we can do that as well, and much more. So we've got a booth out here. A couple of my colleagues happy to talk to you. I'm happy to talk to you, and that's us. Is that pitchy enough, Normal? All right. Thank you all. Enjoy the conference.
It takes a lot to run a conference like this, especially for the last 8 years, and CPRIME has been at the core of the volunteer organizers and volunteers that run this conference. So just like to give an extra shout out to CPRIME for letting us borrow their employees after work and helping out. So if you want to give there you go. Speaking of which, I will be putting up, I think during the break, the lunch break, there'll be a slide, but if you're interested in volunteering or becoming an organizer for this conference, we are always looking for folks that are passionate and engaging with this community, want to help out. So there'll be some more details on what the difference between an organizer and a volunteer are on the slides at that time. Oh, that's tricky. If you're interested in potentially volunteering next year or becoming a full-on organizer, please reach out to anyone that's in a salmon t-shirt, and we'll get your name for next year. It's really great. It's a great group of folks that put this all together or are passionate about providing a place for folks to learn new things and engage with the broader RTP and Raleigh-Durham area of tech subject matter experts and bringing speakers from around the world. I remember in 2019, I believe, we had folks fly in from the Caribbean to attend DevOps Days Raleigh. We had folks from Canada and all over the world. Canada, there you go. Really on the edge there. So it's not just the triangle, but bringing the world to the triangle as this community grows. So please consider being a volunteer or organizer. And are you all ready? All right. Please give a warm Raleigh-Durham welcome to Cecilia Martinez. There we go. And
all right, I am on. I'm Cecilia Martinez. Let's see.
Because we were testing in Prague.
Yeah.
Which is right now. There we go.
Let me just restart the presentation. How do I get this going in here?
There we go.
Okay, we're back. So I'm aware that I am the last thing between you and lunch. We're all in this journey together, so I appreciate everyone's participation and patience with me today. This is testing in prod as part of the pyramid. If you'd like to grab these slides and follow along, you can feel free to scan the QR code on the screen. If you want to watch the presentation first, then decide if you want the slides or not, I won't hold that against you. I will be showing the QR code again at the end. But feel free to scan and follow along if you prefer to see it on your own screen as well. So to start, who here has ever pushed a bug into production? Let's see some hands, okay? So I see people who have and people who are lying. So now raise your hand if you pushed a bug into production even though all your tests passed. Okay, yeah, right. So some of you are just pushing even though your tests don't pass. Maybe don't do that. But the point here is that testing is supposed to give us confidence that our application is going to work as expected for our users. But that obviously does not always happen. Our tests are passed, but then we still end up with bugs in production. So we have better and better tools out there for improving observability, debugging, and monitoring that allow us to deal with bugs when they happen rather than trying to prevent them in advance with testing, because there are bugs that get through, right? These tools are typically used by developers retroactively and reactively after the fact. So, for example, the last company I worked at, a company called Replay, we had really great error monitoring alerts. And we spent a significant amount of time adding new categorizations in our source code whenever an unknown error occurred. That way we could better track them down the next time it happened. Sometimes we have a bug, we add the categorization, we tell the user, try it again. It's still not going to work, but at least now we'll have more information about why it's not working. But again, this is a very reactive after the fact type of approach. So how can we leverage these tools, but from a testing lens versus one of monitoring and debugging? So to do that, we're going to talk about testing in production. This is a quote from Charity Majors about some of the misconceptions around testing in production. Test in prod has become shorthand for all the irresponsible ways that we interact with production services or cut corners in our rush to ship. We all seem like the memes of, I like to live dangerously, I test in prod, right? But the phrase seems to insinuate that you can only do one or the other. You either test before production or test in production. But that's a false dichotomy. All responsible teams perform both kinds of tests. So if testing at its core is about increasing confidence that our application is going to work as we expect it, then testing in production means applying those same quality principles that we use for testing pre-production to increase that confidence. Once we think about testing in production within that quality paradigm, or as part of the testing pyramid, so to speak, there's two major questions that emerge. The first is, how can we take a quality-focused approach to testing in production? The second is, how can we incorporate testing in production to our overall testing strategy? So they're two sides of the same coin, where we're bringing quality concepts into prod, and then we're also taking the data that we learn from our production testing back into our overall quality strategy. So to help answer some of these questions, these are the things that I'm going to talk about today. I'm going to talk a little bit about pre-deployment testing in order to highlight some of the principles that you should be thinking about while you're developing your testing and production strategy. I'm also going to talk about some definitions around testing and production, talk about some of the tools that are available to help you do this, as well as some of the strategies and specific use cases that you may have for testing in production. So as far as I go, why am I here talking about this? Well, I'm Cecilia Martinez. You can follow me, find me on GitHub and Twitter at Cecilia Creates. In addition to my work in tech, I do a couple other things in the community. I volunteer with Women Who Code, and I'm also the head of the Atlanta chapter of Out in Tech, which supports the LGBTQ+ community in tech. So if you're interested in either of those things as well as testing, mobile DevOps, web development, feel free to connect with me. and ask me questions about that. But, you know, I don't work for a feature flag or observability company. I'm not in an SRE. I'm a developer advocate for AppFlow, which is a CI/CD platform for shipping mobile applications. But before that, I was at a company called Cypress, based in Atlanta, where I live. I was there for 2 years, and it's an open source framework for testing applications in the browser. I was about the 20th employee, pretty early in, wore a lot of different hats in the success team, and eventually was the first technical account manager there. That entailed working with our enterprise users to help them integrate Cypress into their CI/CD pipelines, and also work with them on their testing strategy. I would do what I call test strategy evaluation sessions, where I say, pull up your test code, pull up your workflows, let's take a look at it, I'll ask you some questions about your strategy, and we'll kind of jam on how we can make it better. So I spent a lot of time analyzing and seeing different real-world implementations of testing in production, or real-world testing pipelines. And I will say also, just as a side note, if you ever feel like imposter syndrome about your test code, like, do not worry. I've seen it all. Like, you would think that like these big companies with all these developers and dedicated quality teams would have pristine test code, pristine test environments. It's very different in the real world. So as long as you're writing tests, that's a great first step. So through this, over time, I did start to see more teams start to incorporate testing in production tools. So I talked to teams and they're like, we have these tools that we're using, and how can we incorporate that into our strategy? But they were usually using these tools from a developer perspective in a reactive debugging approach. So I wanted to better understand how we can apply those pre-deployment testing principles to what they were doing in production. So to start, let's start by looking at the types of testing available for traditional pre-deployment testing. Just to kind of get a read of the room, who here comes from a quality background or has done testing or has set up kind of testing strategies? Okay, so yeah, so it'll be new for some folks, but there's a lot of different testing paradigms, and all of these approaches that you can take to testing in pursuit of this like perfect unicorn, like perfect ratio of test types, right? Yeah, there's the testing trophy. How many of y'all seen the testing trophy? Most people. Okay, so this is from Kent C. Dodds. Basically, it's write test, mostly integration, and it has this shape ratio, end-to-end integration unit and static testing. There's the testing crab by Gleb Bomatov. I don't know if anyone's ever seen this one, but this is essentially a large chunk of functional and visual end-to-end tests built on a base of component, unit, and API tests, covering different aspects of your system, trying to balance out speed and effectiveness. And then, of course, the classic testing pyramid, where you have a base of unit tests with integration and end-to-end tests built on top of that. But ultimately, the type of test that you write will be based on the testing goals for your specific application, right? And that's what I found after doing all of these test strategy evaluation sessions and talking to the testers, that nobody really likes the answer, it depends, right? But as in most things, when it comes to testing strategy, it really does depend on certain questions. It depends on what is the structure of your application, how do you deploy it, what does it do, what are your user and business goals, and what are your developer experience goals. For example, if you have complex business logic, then unit tests become very critical. You may have more of those. If UI and styling is paramount to the way that your application functions, you may incorporate visual testing. If you rely heavily on external systems or external APIs, you may have more contract testing. And of course, there's also API component and end-to-end testing for validating the functionality of the pieces of your web app, as well as how they work together, and that may be used across different implementations or systems. So whether you have a dedicated quality team or whether quality is primarily owned by developers at your organization, you've likely, hopefully had a discussion on what types of testing that you're using, as well as what the coverage goals are for your testing. So by coverage goals, I'm talking about code coverage and test case coverage. It's important to have both of those, because you can have 100% code coverage and everything does not work. And so when we talk about what the goals are for the coverage of your application, we're talking about both of those. And again, you hopefully have a strategy in place for how you're maintaining tests, how you handle failures, and how you're creating and managing the environment, including the data that you're using for testing. So I talk about this to show that there isn't specifically one clear-cut strategy for testing pre-deployment, and the same applies for testing in production. However, there are certain things that you will take into consideration as you're developing your strategy, specifically what your goals are, and from there, building out the types of testing that you're going to use, what your goals are, and how you're going to maintain and with the tests that you have. All right, so let's actually get into testing in production. So testing in production is not meant to replace testing that takes place pre-deployment. Please still write tests. You know, like the quote said, all responsible teams perform both kinds of tests. It's a false dichotomy. You don't need to do one or the other, you do both. So how does testing in production fit into that overall strategy? Well, let's start with some definitions. This is one from Optimizely. So testing in production is a software development practice in which new code changes are tested on live user traffic rather than in a staging environment. It is one of the testing practices found in continuous delivery. I also wanted to note, you may see the term progressive delivery instead of continuous delivery. Progressive delivery is focused on the shipping of features with a greater shift to testing in production. So you're not necessarily thinking in terms of releases where you're saying whatever changes that you have available, whatever code is ready to go, you ship that out as a release. Instead, it is focused more on features. And features are rolled out or rolled back independently, using something like feature flags based on results of the testing in production. So this represents kind of the frontier of delivering to users quickly and efficiently, but also responsibly, and being responsive to what you find from testing in production. There's definitely some benefits of testing in production. The one that I think speaks to a lot of people, the one that kind of people mentioned first, is greater environmental accuracy. There are a lot of pain points when it comes to replicating production environments for testing. How many of y'all have tried to create ephemeral test environments that match the same as production? And yeah, so I feel your pain. At Cypress, I did an actual 2-hour workshop just on test data management. Like that alone, 2 hours talking about how to manage your test data and set up those environments. So even when you have test environments that are really focused on having high fidelity, there are inevitably things that you're going to need to mock out, right? So greater environmental accuracy is one of the things that is a good benefit of being able to test in production. The other is, if you're set up to test in production with the right tools and strategies in place, with the right tools and strategies in place, then you can have more control over your deployments. You have deployment agility, so that you can feel more confident in your ability to deploy either your entire code base, specific changes, or roll back as needed. You also get more nuanced testing information. So in Sarah's talk earlier about observability versus monitoring, we talked about kind of what are the things that we don't know that we don't know. So testing, when we have it pre-deployment, we're constructing that world for ourselves. Testing is based on the arrange, act, assert model, right? So you set up your test, you do something, and you write an assertion, did something happen or not? Was it true or false? Did the test pass or not? With testing in production, we get data from a wider range of sources that we are then able to interpret and utilize to bring back into our quality strategy. So we're dealing with the real world, not something that we have constructed. There are also obviously some limitations when we talk about testing in production. It does require you to have modern deployment set up. You have to have that agility in order to be able to do testing in production so that you can construct and control things if things don't necessarily work out as they're supposed to. You also need to have a strategy in place for your data and security management, making sure that you're leveraging the right types of data, the right types of accounts, and you're not impeding on anything that is happening in production that should not be. This requires some forethought in terms of what your goals are and how you're going to interact with your production data. There's also the potential for outages or bugs related to implementation. These are things that can go wrong that are not the result of your code and your application itself. You see this in testing pre-deployment, right? Like a test fails, And the first question is, was it the code base? Was it the test code? Was it the test environment? Do we just need to rerun it again and hope that it passes this time? So that carries over to production as well. You could have things go wrong and it has nothing to do with your app itself, but rather how you've implemented your testing and production system. So having really great monitoring observability and leveraging those tools to get a clearer picture of what has gone wrong will be important as well. I did want to make a quick note that for this session, I'm focusing on application quality testing because, to be honest, that's what I know the most about. And there are other types of testing that fall under the umbrella of like testing and prod. We'll probably hear some great talks today and tomorrow about some of these topics, but that includes performance testing, security testing, stress testing, and recovery testing. These are focused more on the systems that you have in place in order to distribute your application versus the application quality itself. So, all right, so let's talk about the tools available for testing and production. I have mentioned feature flags a couple times. These are available. You can either build them out yourself with configuration or like just simply just booleans in your code. There's also tooling that you can use to get these set up. They're also called toggles or switches, and they turn functionality on and off in production without deploying new code. How many people have feature flags in their system set up? Okay, awesome. And this is something where you can introduce it like with one thing, or you could have them spread throughout your entire code base. Sometimes they're spread throughout your entire code base because you forgot to remove them, and they're still there. So this is used for graduated rollouts, where you are essentially incrementally increasing the number of users that have access to a feature, or for split testing, where you're testing different versions of a feature implementation. It can also serve as a kill switch when things go wrong, right? If you need to roll back quickly, you can just update the feature flag and you don't have to do a deployment. So it separates deployments from releases. So you can deploy code, but you release features using something like a feature flag. Then there are monitoring and observability tools. Again, monitoring and observability tools are tools that are used for monitoring for observability, but then can be leveraged for testing and production. So monitoring is about gathering predefined metrics or logs, so that's focused on what we know. And observability is about exploring finding things that are not defined in advance, so things that we don't know. Again, Sarah covered a lot of this earlier with much more nuance and detail. And so these are reliability tools that can be used for testing in production as part of the strategy there, even though they're primarily more about observability and debugging and performance. And finally, there's some other tools that you may not think of as testing tools. However, when you approach testing in production with this quality perspective, these can come into play. The first is product usage analytics. There's a lot of options here. Essentially, these are quantitative metrics of how your user is interacting with your application. So things like feature usage, page visits, time on page, anything that you would want to track. You can leverage that as part of your testing and production strategy to see how users are actually interacting with features quantitatively. You can also get qualitative data from tools that are like session replay tools. These actually record a user session remotely, which then you can then play back. These are things like LogRocket, Full Story, Crazy Egg. I use all three of those. But that allows you to get qualitative data around, how long does your user wait before clicking a button? Like, do they get confused about the certain user interface that's taking place? And then you also have qualitative data collection around things like satisfaction surveys, support tickets, user feedback, things that you can then take into consideration as you're evaluating your test. So how can we use these tools together for an effective testing and production strategy? So it's important to remember that testing and prod is still testing. Focus on that testing aspect. We design a testing strategy based on, again, as I said, the architecture of our application, how we deploy it, and our goals for testing. There's not a one-size-fits-all approach. So there's going to be different approaches that you can take based on what those goals are. So we're going to look at some potential scenarios and how you can implement a testing and prod strategy for each of these. For each scenario, we'll talk about what the scenario, how we define it, talk about what tools will be used, and some of the requirements for that approach. The first is feature experimentation. This is when you're evaluating features, an aspect of a feature, or how to implement a specific feature. This is typically what we call split testing with feature flags. This will require investment specifically in product usage analytics. So if you don't have good product usage analytics set up and you deploy an A/B test of using feature flags, you're not going to be able to get helpful data about how that test has actually gone. So again, the product usage analytics provide things like how people are using that feature quantitatively. You will also need to have very strict definitions of success and test conclusion criteria. This is an experiment. You need a hypothesis. You need a definition of success. You need to know what being done looks like and what results look like. So for example, I asked earlier, I mentioned having feature flags that are still out there. How many people know for a fact they have feature flags in their code base that they no longer leverage or have been turned on forever? Okay, a couple people, yeah. So one thing that I see too is starting an experiment without knowing what it is that you're hoping to accomplish with that. So having very specific criteria for how many, whether it's time-based, whether it's traffic-based, whether it is we have a certain number of data points that we can then analyze in order to make a decision how we'd like to move forward. So feature experimentation is specific in that it should have a start and an end with defined criteria. The next is production uncertainty. So this is where you have a production environment that's really difficult to reproduce for testing, and you are worried about deploying new changes and how that's going to go. So this is if you have, for example, really complex external services, if you have a really complex data model that's difficult to create a test data bed for testing, and you make changes to that data model. You could have complex containerization or deployments, again, that are difficult to reproduce in a test environment. So last company I was at, Replay, we had a very complex deployment strategy, or a back end really, that required us to spin up multiple containers, and then within those containers run hundreds of browsers that would replay a recording of a browser session using code. That would then connect to the front end of the application in order to render what was being replayed in the browser. So it's kind of like a Monte Carlo simulation with browsers and containers every single time somebody uses the web app. So that's really, really hard to reproduce. It's intensive. And so that's where we had those really specific monitoring events defined in advance, so that every time we pushed out a change, we right away could see what was pinging, and we had a strong strategy for being able to roll back. So this is where we talk about not necessarily split testing, but graduated rollouts. And graduated rollouts, you'll still kind of use feature flags, but use a different function of feature flags where you're only exposing that change to a percentage of your users at a given time. And then that's to minimize the blast radius, essentially, to prevent that from affecting as many people as possible. We even see this now in mobile development, where you can do phased releases of your mobile applications that only certain users are getting it, and then once you feel comfortable, you expand that out. You will definitely need to have investment in monitoring with events that have been defined in advance, specifically for high-risk areas of your application. So what I would call the money line, or the money path, where if it breaks, you're not making any money and everything is bad, as well as new areas that could be considered high risk. And you also need to have strict approval criteria for how you're expanding to impacted users. Again, that could be time-based, it could be traffic-based, it could be, it's been 20 minutes with zero incidents. But having that defined rollback and recovery plan is really critical. One time, prod went down and I was in the middle of a live stream about to do a demo, and I'm discording them hey, it's not loading. And 3 minutes later, it was back up, and I was able to continue on with my live stream. So having that mature deployment strategy for these types of being able to roll back is really important when you have production uncertainty. Next is usability. This is a different use case. This is specifically for product and UX validation. So how are your users interacting with your new feature? This isn't feature experimentation where you're necessarily having different implementations of the same feature, but this is validating, like, is this feature something that we're going to move forward with or not? So you're still going to use split testing, but instead of having different implementations, it's going to be more like a Boolean, like a yes or a no. For this, you'll want to invest in session replay and qualitative data collection. So this is something where if you've ever done like user testing with Figma mocks, say like, how will we click through this? You can do this, but you can do it in production. And so you're going to want to really see how your user interacts with your product in order to validate how you'd like to move forward with that. And then this last one is experimental. So this is to help you identify unknowns when you have a complex change and you're not sure what you don't know yet. So this could be things like you're doing an API migration, you have an architectural change, you're making a tech stack change, maybe updating some dependencies, or you have a brand new feature. Typically, this change has been well tested, but you're not confident that all test cases have been identified. This will also be a graduated rollout, but again, separate from the production uncertainty graduated rollout, this is based more on identifying potential unknowns. Production uncertainty graduated rollouts are based on reliability with defined events. Experimental graduated rollouts are going to be based more on observability to identify those unknowns. And so you're going to want to make sure that you have invested in observability and your system is set up for that. You typically also will do this with cohorts of user types. So it may not be just a rough percentage base, but because you're trying to identify and isolate things that you don't know, reducing the number of variables that you have can be helpful here. So if you have certain user types or different cohorts that may have different types of interactions with your application, doing graduated rollouts to different cohorts can be helpful here in just identifying things that you may not know. And so being able to identify those patterns can be really helpful there. Whatever approach that you take, just make sure that it's intentional. Again, we're taking that quality approach testing in prod. Experiment with intentional testing based on one specific goal to start. So if one of those use cases that we just went through applies to your organization, you can pick something like that, or you can start with something else. But testing in production can be a really valuable part of your overall testing strategy because of those benefits we talked about. They're real users in a real production environment, and that's something that you can't really replicate. So yeah, I have some resources here, things that you can kind of use to get started and cover some of the topics that we talked about today. And you can grab all these links from the slide. Again, you can scan the QR code there, and feel free to find me again at Cecilia Creates. Thank you all so much.
All right, thank you so much, Cecilia. One more round of applause. All right, before I let you all go for lunch, there's one thing that we're going to do after lunch that's super awesome. So we're going to have the Ignites talks, which are awesome, and then we're going to do something called Ignite Karaoke. Ignite Karaoke is some of the funnest stuff that we do at DevOps Days, and since a lot of you, this is your first DevOps Days, I can almost feel the nervousness from when I just mentioned that. Don't worry. Ignite Karaoke is, we need 5 people to volunteer to participate. This is after lunch. And the way it works is it's a 1-minute presentation that person's gonna do with 4 random slides that auto-advance every 15 seconds. Again, that's a 1-minute presentation with 4 slides that auto-advance every 15 seconds. You don't know what's on the slide, and you can just present whatever you want. So, okay, we got Aaron to volunteer. So I need 4 more volunteers for this afternoon. Come up to me, or when we call for the Ignite Karaoke, we'll line up. You don't have to sing. I mean, you can sing if you want. So if you're interested in that, we need 4 more volunteers. It's a lot of fun. Don't be afraid to come up. And with that, we'll come back at I believe 1 o'clock. For the Ignites. Oh, and lunch is right back behind there in the rooms to the right. And as you're all leaving the room, unused feature flags, oh how they sway, in the code base day after day, waiting for the day they'll shine, but until then, they bide their time. The product team once had great plans, but priorities shift as they often can. And so the flags remain untouched, their potential forever unclutched. There we go.
Do we?
Yeah, no, I'm asking.
No, not
Do you have
since
a phone number?
she's the only one that doesn't have a phone number. So I was actually going to ask you about that because I didn't see it in here anywhere, and I hate to even bug you with this. Yeah, like in the phone field, it's just her email again.
I mean, we did get an acceptance from her. It should say a date.
Yeah, I mean, she sent me her slides last night. So, like,
Maybe she just one of those. But be prepared to skip hers.
So, yeah, I mean, it was funny because she said she never got the request for the slides, which she definitely did.
Yeah.
So, but anyway, she also wasn't up on the Ignite one. It's like, it's only a 5-minute presentation, I think, right? So here it's not much, it's only 8 slides. And I was like, well, Ignite format calls for, this was all explained in the email.
This was explained when she submitted it.
Exactly. Well, it's been explained multiple times. So she was like, I never saw a call for the slides, but here they are. There's only 8. But she did expand the slides and sent them over like later that night. So
you never know what you're gonna get.
That's true. But I mean, one good thing about it is it's like she expanded it to I think 16 slides, closer. But it's a little.
Where's Michael?
Robert?
Yeah.
He was just right here. Why? What's up?
Someone wants to test their Monica and Daniel want to test their laptops.
All right, I'll go grab them.
Yeah? Okay.
The GPT poem was a hit.
Someone came up and was like, can you put them on a slide? Like all the ones I'm going to do today?
You could do it in real time. That would be fun. Do like a live generative demo.
Yes.
You could even do like crowdsourced prompts from the audience.
Yeah.
I will be definitely doing that later today.
Anyway,
I'm already taking
worst case, if she's just flakes, like she's the first one, her talk's weird, it's only 5 minutes, it's fine. But I kind of think she's gonna roll up in here like 10 minutes before her talk.
Today?
Our first Ignite speaker after lunch.
We don't know where they are.
She sent her slides over last night.
She's just kind of flaky.
Who was it? A couple years ago, there was someone who was.
Go back up here.
I'll just let me look for you.
Yes.
How you guys doing? Hi, I'm here. Nice to meet you as well. Tell me one more time about this karaoke. You already have fun.
I think I had 4. Maybe.
We have 5 now. Sounds like
We
me.
got it tomorrow too, so just
Yeah,
pick up the
there's
first
another one tomorrow as well.
Okay, yeah. Oh,
Okay,
good. Then
so
I'll
you'll
go
be the-
tomorrow so that I can see.
There you go.
today.
You'll see. I'm not even going to spoil it.
Okay, remember me. I'll do tomorrow.
I like this person. It is very fun.
Now we
It's
know
very
who you
fun.
are. Exactly.
Oh,
I love that you
I'll
don't know what you
tomorrow.
volunteer for, but you're definitely
And I mean, it's only lasts like 60 seconds, right? I mean, how
Yeah,
bad
it
can
could
it
be like the worst 60 seconds of my life,
No,
but I'm okay with that.
there's almost no way for it to be bad because it's one of those things. It's like, you know, honestly, like the worse it is, the better it is because it's just entertaining. Yeah. Because I mean, there's not supposed to be any substance to it.
Okay,
I mean, there can be if you want to go for it, but it's really more about comedy.
Okay, sounds fun. All right, great meeting you, Chris.
Yeah, I'm Chris.
Okay.
Tia?
Tia, yeah.
Well, thank you for your interest. I hope that you'll
Of
do it
course.
tomorrow.
No, thank you for this conference.
Oh,
Amazing.
yeah, for sure.
Yeah.
So funny. This thing is it's clearly the exact chime that they use for the default text message alert.
Yeah.
The first year I went around and dinged that thing. It was like the looks. Yeah, you'd see people check their phones, and then like when they realize where it comes from, they give you like a dirty look. I got so many dirty looks from that thing, man. Which kind of made it that much more enjoyable.
Why are there 2 people now?